making sure everybody knows, as you can see, we're very tight in here. We tried to cram in as many people as possible because we're very fortunate to have Bart here. You know, he knows everything and anything about YKK. I always do this to him. And
then they're going to ask me questions I can't answer.
You know it all. You know it all. But if you would, through today, please just at least silence your cell phones. I know some of you will get calls that you may have to step away from. If you can avoid getting up and leaving, no, it would be great, just because it's disruptive. We have a lot of people in here. So just make sure your cell phones are silenced, and Bart is kind. He will give you some breaks so you can go, you know, use the bathroom, get something to drink, take a smoke, whatever you need to do. So we'll just wait for those few more fabricators, and they're going to have a front row seat because they're late. So, okay, just 2 more minutes, guys.
This has got to be better than being outside today, right?
Actually, it's one of the things we wanted to be outside.
I thought of that. I was like, do you believe it's finally warm and these poor guys are sitting inside today? I did think about that. I'm sorry, but Mother Nature had other plans.
I looked at the weather coming up here last week. I looked to see what the weather was going to be like up here, and I go, well, hell, I don't know what everybody up there complains about. It's about like it is here in Atlanta.
We had a few really bitter days.
Yeah.
I mean, these poor guys, it was cold out there for sure. It was cold.
Like I said, he's shaking his head. This is Wait, you see where's it now? Like, and we're putting regular doors. They're regular frame saver. Yeah. That's shit. There's one right to the right.
Good morning. Yep, right here.
Morning. Good.
Doors and storefront. Who's this from? All we need are jumpsuits. That's it.
You got your orange snacks.
Are you guys hot, cold? Hot, or you turned down the air a little bit more? You already did? Okay, good, thank you. Alright. You didn't answer me, so we'll get started. Yeah, and we're missing some. That's why we've been holding out. I don't know where they are. Say went to wrangle the troops. All right, guys, we're gonna get ready to get started. Good morning, all. Thank you for spending your day here today. You know, part of what we believe in is not only do we hire you guys who are, we feel, the best out there, but we also want to make sure that we give you the tools to do the best job possible day in and day out and be educated in what it is that you are installing, understand what you're installing, and give you the opportunity to not only be the best you can be, but represent our company the best possible way. Come on in, guys. We have 2 seats up front. We have 4 seats up front. Yep. I promise Bart doesn't bite.
There's another seat right up here.
Yeah, there's one. You want to come up here?
You'll need a book.
Yeah, it'll be easier for you. Okay. So in all that being said, we're very fortunate to have Bart Harrington here from YKK. He is based out of their headquarters in Atlanta, Georgia. He has been doing this a very, very long time. Long time. He is the one that actually, a lot of times, if there's an issue on a job site, there's a leak, he goes out and he figures out what went wrong, and 9.5 times out of 10, it's an installation problem. So that's why he's here, to make sure that you're all trained and we don't have any of those issues. It starts with fabrication, as you all know. That's why fabricators are here too today, all the way up to installers, and then our field supervisors, making sure it all goes in. We're also very fortunate to have today with us, this is Jim D'Arcangelo. He is the Northeast Sales Manager. Michelle, what's that?
Sales, yep.
Yep, sales. Michelle Pearson, she is sales for the Maryland territory. Jim Zester here is the branch manager of Baltimore, which is, I would say, one of the largest, right? Yeah, the largest area distribution, yeah. In addition, we have Ivan Zuniga. Okay. He is in charge of, he's the director of product development for YKK. So if you have any suggestions, any product ideas, he's the guy that you want to pitch them to. And then we feel very honored to have Mike Turner here today. Mike is the president of YKK. So we are very fortunate to have you here today. So we're looking forward to a great day. I'll let them have the floor, anything that they want to say. Again, please silence your cell phones. Try not to get up until Bart gives you breaks. We will have more donuts in the back at break time, coffee. I'm not sure if it's quite ready. There's water and sodas in the back fridge. We will be providing you lunch today. So have a great day. Thank you. Where's Matt? Does Matt want to say anything? Where did you go? Okay. Okay. Please, the floor is yours.
Thank you.
All right. Thank you, everybody. Have a good day.
Thank you.
Jody,
Yes,
is this going to be an all-day thing with us here tonight?
it is. It is.
So we're going to be up here all day?
Yes.
Okay.
Yeah, till probably about 3 o'clock.
Okay.
Did someone not communicate that to
that's what
you?
we want to make sure.
Yes.
No, they just told us to come upstairs and there's a group coming down, a group come back.
Yeah, we divided you guys. I apologize. They were supposed to let you know
Okay, I
that.
just want to make
But I will make sure if you have work on your boards that you were supposed to
Right.
get done today, you will. We'll discuss that. So
Thank you very much.
okay. All right. Thank you guys.
You're welcome.
Have a good day. Did you want to say anything? They said you went that way. I was like, oh wait.
No.
Yeah.
Hi, everyone.
He's the one you see most of the time. Half of you probably don't even know who I am, right? All right. Have a good day, everybody.
Thank you. Well, here we are, all day long, sitting in those chairs, listening to me talk. Again, good morning. Jody introduced me. My name is Bart Harrington, and I am the Field Technical Services Manager for YKK AP. I've been with YKK AP for going on 18 years. I've been in the industry for 40 years. So actually, my background is I went to college for a couple of years, decided to be a jarhead, joined the Marine Corps. We got any jarheads in here? None? Oh my gosh, that's unbelievable. So I served in the Marine Corps for a while, decided to go back to college. While I was working, I got a job working as a fabricator. While I was going to college, I got a job working as a fabricator for a glazing contractor in Atlanta. And ended up, after I graduated, I got hired by a company called Conair. Any of you guys know Conair? And I worked for Conair in various capacities for about 16 years. I was in field sales for 8 years. I ran the training department at Conair for 4 or 5 years. I was a curtain wall product marketing manager for 4 years. And during that time, I was also responsible for finishes. I was product manager for finishes and corporate pricing administrator and various things like that. Left Conair after 16 years and went to work for Tremco. Did you guys know Tremco? Okay, so worked for Tremco for a couple of years. Got to know more about glazing gaskets and glazing tapes and sealants and things like that. Left a lot of people that I had known at Conair had transitioned to YKK, so that was a good place to work, so I've been there ever since. So, so I do a lot of training like this. Probably most of my time is spent doing training. I don't do, hopefully because we're doing more training, we're having fewer problems in the field, but occasionally I get drawn into field problems. And Jody's right, most of the time when I get involved, the overwhelming majority of the time, what I find are fabrication or installation errors. And not to say that we don't make mistakes. You guys usually, the thing is we occasionally make mistakes in manufacturing the material, but usually you guys find that out pretty quick. When you guys start fabricating it and assembling it and glazing it and stuff, if things aren't fitting together right, you generally identify it before it actually becomes a leak problem down the road and we replace the material or whatever needs to be done. But today I'm going to talk about the fabrication and installation procedures for a number of products. And one thing I want you to kind of keep in mind is we write these installation instructions. There isn't anything in the installation instructions that's like random. Everything has a purpose. And so what I'm going to do today is not just explain what has to be done. We're going to talk about, why these things need to be done. And my experience has been that usually, I know for me, if I understand why something is important and why it needs to be done, I tend to remember to do it better. Like when my wife tells me to do something, if she just tells me to do something, it'll go in one ear and out the other. If she's telling me I got to do something because this, and this has to happen, then I tend to remember it better. Okay? So I think a lot of us are kind of like that too. Have any of you ever been in one of my training classes before? Oh, okay, good. So you guys know the routine then. Okay, some of you do. All right. Also, Again, I've been doing this a long time. I can stand up here and start talking today and not shut up till the end of the month. But usually this is more interesting for all of us if this is as much a dialogue as it is just me lecturing you. So by all means, if you have any questions or comments, please feel free to raise your hand and we can talk things over. Okay. And are there any open seats? I think there's one here, and there's two seats, one here and one right there in the middle, so you guys can squeeze in. You look like Larry Bird's little brother, doesn't he? A little bit. There's one right here. The books are yours to keep. The books in front of you are yours to keep. We're going to be going through those, so feel free to use the pens and the highlighters to mark them up and make notes. One thing you'll see is that there's installation instructions in here. Towards the back of the book, there's a tab that says notes, and those are just lined sheets if you want to write things down. Okay? All right, you guys look like a pretty experienced group. So this will be a lot of fun. Okay? So the first thing that we're going to do is go through the installation instructions for our storefront system, YES 45TU. You guys know what the meaning of YES 45TU is? Anybody?
The size of the frame.
Well, that's part of it. What's YES? Anybody know what that stands for?
Yes.
Yes? Yes, you do, or that's what it stands for?
No, they don't.
Okay, so what do you think the Y stands for? Anybody want to guess what the Y stands for?
YKK.
There you go, YKK. And so when you see the ES designation, that's the designation that we typically put on our storefront systems. ES stands for entrance system. So we consider storefront systems to be used for ground floor applications, which almost always includes storefront doors and so forth. And again, understand that storefront systems are designed for those types of applications. So your strip shopping centers and things like that are what storefront systems are. When you see a number in the product name, that typically indicates some nominal dimension, typically the depth of the system from front to rear. And so this particular system is a 4.5 inch deep storefront system. And then what about the TU? What do you think that stands for? Thermal, and it's not unit, but your thermal is correct. So when you see the T in the product name, aluminum is thermally conductive. So if the outside of the aluminum gets cold, the inside is going to get cold. Okay. If you've got the HVAC system running and it's winter time, the aluminum on the inside will get warm. It'll also warm the aluminum on the outside, and that's inefficient. And so because aluminum is thermally conductive like that, we put a thermal break in the system. And in this particular, that's what the T stands for. The T is indicating that there is some manufacturing modification to the system that enhances the thermal performance. In the case of this product, the U stands for urethane. That's that black strip that runs down the center of the glass pocket. That's polyurethane, and that's less conductive than aluminum. So that's the thermal break, and we'll look at some details right here. So these are the standard product details. The standard configuration is set up for outside glazing. So looking at these horizontal details right here, this would be the outside, this would be the inside, and of course we have removable glass stops on the exterior for being able to set the glass. So this red thing that you're seeing here, that's not really red in real life, is it? No, it's black. And again, it's urethane, and it's designed to thermally isolate the outside aluminum from the inside aluminum. Later on today, I'm going to talk to you a little bit about thermal performance, just because one thing that we're seeing in our industry is a lot of advancement in specification writing on projects and newer systems that are coming out that are more thermally advanced than the older systems are. And we'll talk just a little bit about thermal performance and how these thermal features work on the systems. These are your vertical details. This is your jam mullion. Again, thermally broken. Same thing with the vertical mullion. With the pocket filler, typically you guys are doing screw spline fabrication, correct? So again, your vertical mullions will be two-piece members that are designed to snap together. And then, of course, the horizontals, in terms of your assembly, feature, what are these? Those are screw splines, or some people will refer to them as screw races, okay? The systems, all of our systems are designed to be internally drained, okay? What internal drainage is a concept that there's not a practical way of preventing all moisture from getting inside the system, okay? We know that after, even if you follow the instructions properly, there will be some water that penetrates into the system, okay? There's two things that we have to do for water when it gets inside the system. We have to control where the water goes inside the system. We only want it to be able to go to certain areas. And then what's the second thing we have to do?
Drainage.
We got to get it out, okay? So all of these installation instructions and a lot of the steps that we're going to go through when we talk about this is going to revolve around managing the water while it's inside the framing system and then getting it out, okay? And so what do we have down here at the very bottom of the framing system? This gray, this dark gray. Yeah, it could be called a subsill. If you look at our price book, our terminology is sill flashing. It's about 50-50 around the country. Some people call it sill flashing, some people call it subsill. But its primary purpose is to be where all the water that enters the system ends up, okay? Assuming you've installed everything plumb level and square and everything has been, installed and sealed properly as you've assembled and glazed the system, water will end up at the sill flashing at the bottom. And then we have what? To drain the water out to the outside. What's right here?
Weep holes.
Weep holes, okay? But we're going to talk about all of this in greater detail as we go through the installation instructions, okay? Yes, sir.
That on that last slide, what's on? That's the slide. That's the screw right there in front of the subsill.
Right here?
No, the next one.
This one.
What does the green represent?
The green represents sealant, okay?
Okay.
Just for the purpose of, obviously, it would be cool if you could buy sealant that color, but you can't. I just put it that way in the slides just to kind of demonstrate. You can see right here, we show sealant, the perimeter caulking, and then sealing over the screw head. If you've got a penetration in the sill flashing, you better seal those screw heads, because what's going to happen during a wind and rain event or during a field water test is this is going to fill up with water. And all these screws are going to be underwater. And if they're not sealed, what do you got?
Rust.
Well, you got leaks. Rust is also what you get. Okay? Installation. So again, if you want to follow along, this is what's in your booklet under that first tab, YES 45TU. Has anybody ever not seen this installation book before or seen something like this? Okay? So these are the fabrication and installation instructions for this product. We have instructions like this for all of our products, and it's not like a secret or anything like that. Anybody can go to our website and download a copy of these instructions and print them off or just read them. So, if you're out on a job site doing your job, don't be shocked if you see an architect or a general contractor walking around with this. It's not password protected. We want it out there for everybody to be able to see. And sometimes the guys in the field get the architect or a building envelope consultant or the general contractor walking around with a copy of these things. If anybody goes to our website, they can download it and print it. Okay. One thing I want you to kind of look at too is at the bottom there's a little copyright. There's a little copyright number. We make changes to the installation instructions once in a while. And when I say we make changes, usually it involves a new part that's been added to it as an option, or changing fasteners, or, usually it's very minor things. Sometimes it can be a fairly major thing, like when we redesigned our sill flashing. That was kind of a major thing. But my point here is to kind of let you know that it's a good idea to when you're working on a project, make sure that you have the most current version of these installation instructions, okay? A lot of guys will keep, an old copy in the truck under the seat or something like that and pull it out every once in a while. And the next thing you know, the damn thing's 10 years old and it's got coffee stains and all kinds of, and it's all beat up, but it's out of date. So my point here is to make sure you've always got the most current version. In fact, that's just got the year it was last modified, which is last year. But if you go beyond that, it actually shows you the actual day that it was changed, okay? And so this particular installation instruction was modified as recently as April 5th of last year, okay? Again, in the case of this particular modification, there were a couple of minor things that were changed. It wasn't anything major. But at any rate, on this page, it says installation notes up here. Most of the stuff on this page is just common sense stuff, right? Like this first item. Do you really need to be told? Do not drop, roll, or drag boxes of aluminum framing, okay? But we kind of put information like that in here. But there is some stuff in here, that is worth looking at. A couple of things. If you look at item number 7, it says make certain that material samples have been sent for compatibility testing for all manufacturers, sealants involved. Make certain that sealants have been installed. Sealants have been installed in strict accordance with the manufacturer's recommendations and specifications. What kind of sealants do you guys use assembling and installing these things? What are you guys using?
Dynamic or
Spectrum.
What's that?
Spectrum.
Spectrum, silicone, Dimonic. Okay. What else? Do you guys use Dow or just the Tremco stuff?
we used to.
You used to use Dow. Now you're using mostly Tremco. Spectrum silicones and Dimonic, which is not a silicone. Dimonic is a polyurethane. Okay. So the point here is that when we go through these installation instructions, I'm going to tell you it's important to seal this and don't forget to seal that and things like that. What we don't tell you is what kind of sealant to use. And the reason that we don't do that is because we don't know what's appropriate for your project. Okay? There may be things going on, like, for example, the sealants that you use inside the framing system, where you're sealing your vertical to horizontal joints and sealing your water deflectors and you're sealing your gasket corners and things like that. Those sealants need to be compatible with the sealant on your IGUs, your insulating glass units. So do you guys know what your insulating glass units are sealed with?
Butyl acetate and silicone.
Butyl acetate and silicone. So silicone would be, using silicone sealants would be very good. See, we don't know what you're using on your IGUs. And so what we're saying is, and then I'll tell you a quick story to explain why that's important. We were doing a project a few years ago with a customer who, it was a structural silicone glaze project. So this is where you use silicone as an adhesive to glue the glass to the mullions. There's no capture. There's no pressure plate or glass stop holding the glass in. It's just held in by silicone. And the customer did not pay attention to compatibility issues with the sealants, and he bought some IGUs, insulating glass units, that were sealed with a polysulfide. Okay? Now, he didn't know this when he installed it. All he knew was that a few days after he installed it, glass started falling off the building. Okay. Now, a typical day for me is somebody calling me and telling me they've got a leak. That's not usually a big deal. I mean, it's a big deal for you guys. But usually the resolution ends up not being a big deal. A bad day for me is when somebody calls up and says, I got glass falling off the building, right? So, we dug into it, and what we found out was that the silicone, as the silicone cures, it kind of lets off a gas as part of the curing process. And that gas was not compatible with the polysulfide on his IGUs. And it caused the interaction between the polysulfide and the silicone off-gassing caused the polysulfide to revert to liquid. So if you've got polysulfide, cured polysulfide, holding your IGUs together. So what was interesting about it was he had glass falling off the building, but it was just the outboard light on the IGU that was coming off. The inboard light was still glued to the mullion. It was the polysulfide seal around it that was failing, and that outside glass was coming down. So that's why it's important to understand your materials and your sealants and how they interact. And, you know, again, that's not typically something that you guys need to worry about. That's typically something that is part of the submittal and the shop drawing process. And that's why sometimes they tell you to use silicone and sometimes they tell you to use polyurethane. You know, every job's a little bit different, okay? But that's why it's important to understand that, okay? There's another item here, item number 8. It says, remember to isolate in an approved manner all aluminum from uncured masonry or other incompatible materials, okay? What kind of material would not be compatible with aluminum? Anybody? Acid? Well, yeah.
Pressure-treated wood.
Pressure-treated wood. Good. Okay, what else? Uncured masonry, right? Like green concrete that hasn't fully cured yet. What about steel? Are these things that could come into contact with your aluminum on your projects? Okay, these are not things we want coming into contact with the aluminum. Okay, so if you have, for example, steel reinforcement that you put inside the mullions, okay, which one thing you have to make sure of is that the steel is coated to insulate it from the aluminum. Who can tell me what happens when raw steel comes into contact with aluminum?
Electrolysis.
That's one thing that's called electrolysis or galvanic action or galvanization. And what it is it's an electrochemical reaction caused by these dissimilar metals coming into contact with each other. There exists in science a thing called a galvanic chart that lists all of the metals on it. And the further apart two metals are on that chart, the more likely you are to get a galvanic reaction. Okay? And so as it happens, aluminum and steel are relatively far apart from each other on that chart. So when you get steel, and of course, if you're using steel that you're getting from us, it comes with a coating on it. Okay? I don't know if you guys stock steel here or not, but if you're going to a local steel fabricator and buying your steel, then it's probably just raw steel. And so that becomes part of the fabrication process, is making sure that steel's got a coating on it. And the coating, it's not a special coating. It's zinc chromate or bituminous or even just primer, anything to insulate the steel from the aluminum before you slide the steel in. Also, even if you're buying steel that's already been coated, make sure you're coating the cut ends as well. Okay? Yes?
What about the 5 screws? So, they might be coated, but when you screw them in, the coating could wear off.
The fabrication or assembly screws that we use are either zinc plated or stainless steel. Okay, so we don't have problems with the galvanic reaction. Also, there needs to be typically a catalyst. It's not just the two materials coming into contact with each other. There's got to be something that causes it to happen. So as an example, let's say you're building you're installing some storefront framing near a swimming pool enclosure, okay? And there's what's in the air in a swimming pool? Chlorine, okay? That's going to be a very active catalyst. And if you've got steel in contact with the aluminum, it's going to cause a very aggressive reaction. Other ones that you might be more familiar with is when you have a door frame. When you install a door frame and it's sitting down on the ground, in the wintertime what happens? The concrete gets wet, and then what do? They salt and put chemicals down. Those are all catalysts. That's why you probably see a lot of door frames that are all eaten up, where that's occurred over time. Okay, so there's two things about that. One is obviously coating the steel if you've got a steel reinforcement issue. The other is the framing systems, in order to manage water the way we want them to, all need to be installed plumb, level, and square. You guys know that, right? Are the openings that the general contractor gives you, are they ever plumb, level, or square? Yeah, they're not. Okay, and it's probably not. It's not reasonable to expect them to be. So as you'll see as we go through the installation instructions, we don't size the frames to fit perfectly into the opening. We make the frames a little bit smaller, don't we? Okay? The idea being that you're going to shim the frames so that the frames will then be plumb, level, and square. Okay? So that's one reason for doing it. The other reason is to keep the aluminum from coming into contact with the pressure-treated wood, the green concrete, the steel, the other things that you're around the perimeter of the frames with. Okay? So it's not just about getting it installed plumb, level, and square. It's also about isolating the aluminum from these materials that may not react real well with aluminum, given whatever catalyzation might occur. Does that make sense to everybody? Okay, so that's one thing I run into a lot of times is you guys are out in the field and you're working off of guaranteed opening dimensions, right? You guys, who's ever heard that phrase before? What the hell is the guarantee? I don't know what the guarantee is, because what usually happens is, the general contractor wants to order material and order glass and get everything, moving, and you don't have openings yet. Because I'll guarantee that the openings are within whatever the hell tolerance range you guys agree to. Then you get the frames out there and you can't shim them up and make them level. So what happens then is you got low spots. And where does water want to go? The low spots. Is it going to want to drain out? Maybe, maybe not. What are you sealing everything with? If you're using silicone as a sealant, and those screw heads, remember you were asking about the screw heads? What if that screw head's at a low spot and the water just pools and sits on that screw head? Silicone is not an immersible sealant. So if you're sealing your end dams and your screw heads with silicone and you've got low spots and it's not draining out, what's going to happen? The silicone's going to fail, and while it may not leak the day you install it or a few days later, but the longer that remains immersed in moisture, the more likely those are to fail down the road. That's why we have to get everything plumb, level, and square. Okay? These are really important things. Okay? And so again, I'm not going to go through all of these things, but at some point it's probably not a bad idea for you to maybe keep this booklet in the bathroom and read through it, in your spare time, so to speak. Okay?
I got a question.
Yes, sir.
I've seen some of I've seen on curtain wall where people would tape the anchor sometimes to keep from the galvanic reaction from steel, you have to screw the anchor into the steel.
Right.
Is that legit? Like
tape?
Using tape, and if so, what type of tape do you use, or is it?
Well, the only tape that I'm aware of that they would put, and we'll talk about curtain walls later today, but the only tape that I'm aware of would be bond breaker tape that they might put on a moving joint to prevent adhesion, to allow the silicone to stretch. I would tend to think that tape would not be the best thing to put on, because especially in a curtain wall, a lot of those anchors are moving. Like if you have wind load anchors in curtain wall, they might move. And if you have something like tape in between the anchor and the mullion, it's going to rub that tape off, and you're going to be back where you started from. That's why most of the time when you're installing steel anchors like that, you're insulating the steel from the aluminum, either with plastic shims, right, or we actually have a nylon spacer that you slide in between the anchor and the mullion before you drill the hole.
Yeah, but I mean the anchors up top.
Oh, up at the top?
Yeah.
Usually the tape that you're talking about, they're just using it to hold the anchor in place so it doesn't fall out. Because when you go to anchor those up, it's going to pull that anchor out of the top of the mullion anyway. Okay? But I without seeing what you're talking about, I can't. It doesn't sound now. It could be that they're putting tape without the top of the anchor. Okay, yeah, that's probably okay to do, because that's, first of all, that's never going to be seen, and second, it's not going to move. The top of the anchor is going to be hard up to the substrate. It's not going to move.
But it's not necessary, right, to avoid any.
Well, we don't require it. But you may have a building engineer or building envelope consultant that wants to have it up there. And so we see that sometimes on projects. They want to put something in between the anchor. What you can't do is you can't shim the anchor.
Right.
Not for a curtain wall, not the way that you're describing. Okay. Anyway, the next couple of, yes, sir.
Question. So back to the the sub-seal with the silicone caulk.
Yes.
What do you recommend using instead of silicone?
Oh, silicone's the best thing to use.
Oh, I thought you said if it sits in
Yeah, but that's why you have to install it plumb level and square.
I got you.
My point is that if you have low spots, then that's where the water's going to sit. That's why you want it to be level. Okay. Yeah, no, silicone's the best thing to use. Silicone is it stays in its normal state in perpetuity. The problem though is if it is immersed in moisture for a long period of time, it still stays soft and gooey, but it doesn't want to stick to anything anymore. You guys ever seen fogged up IGUs?
Sure.
What usually happens with those is when they fog up like that is either the system is not draining properly and the IGU is sitting in water, or they didn't install the horizontals and the water deflectors properly and water is sitting on top of the IGU. Because when again, the IGUs are sealed with silicone and they're sitting in water, they fail. Now, remember I was telling you about the IGUs that were sealed with polysulfide. So those IGUs were intended to be used in a car wash. That's why he sealed this guy. What this particular glass fabricator did was his biggest customer was building car washes. And so he was sealing his IGUs with the polysulfide because polysulfide happens to be immersible. And when you look at, like when they install storefronts, in the car washes, does it matter if they leak? No. So there's a lot of things that aren't being done right, and so they stay immersed in water. And by the way, the same thing like at wastewater treatment plants, all the concrete, all the things that hold the water, none of those are sealed with silicone. They're all sealed with polyurethanes or polysulfides. Okay, so silicone is really good for us to use because it does last for a long time. And by the way, does anybody know how long our warranty is? Our standard out-of-the-box product warranty is 1 year. Our warranty is that our product is free from defect as manufactured. Okay, you guys as a company have a similar warranty based on your installation of our product. Okay, now does that mean that after a year the wheels are going to come off the wagon and everything's going to start failing?
No.
Okay, how long do you think if you're building a building, if you're the building owner or you're an architect, how long do you think is it reasonable to expect that you don't have to do anything in terms of maintenance or repairs on the storefront framing and glass?
20 years?
20 years? Do you think that's reasonable?
Yeah, 20.
Yeah, I do. There's no reason.
What it's exposed to.
Well, it does, and there's maintenance. There is maintenance. I'm talking about, it's like if you buy a car, or a truck, how long should the finish last? That's going to end up being the function of how clean you keep it, right? I'll tell you, I forgot about this. I used to live. I've lived in most of my life in Atlanta, but I used to live in Detroit when I was a little kid, and I was up there a couple of weeks ago, and I'm driving down the street, and there's all this traffic backed up, and I'm thinking, oh my! And it was like a horrible day. It wasn't a pretty day like today. It was like gray. It looked like it was about to snow or rain. It was cold as shit. And I'm driving down this road. There's all this traffic backed up, and I assume that it's all backed up because there's an accident or something. And I get up there, and you know what they were doing?
Changing the water main.
No, they were getting in line to go into a car wash. Because if they don't wash the salt and stuff off their cars, the finish goes bad. They rust. This is Detroit. And so the same thing is true for our framing systems. There is an amount of maintenance that's required. Washing the glass and washing the metal, things like that. But even if you don't do that, the stuff should, it should last pretty well. Okay? Yes?
While we're on the seal of the units, when you have a heavy door and you're trying to adjust the door with the screw up top, that little plastic piece.
Yes.
That thing sucks, man, because every time the door's go and you try to adjust it, the plastic and will fit down in between the two.
Yeah, you got to turn it.
No, but it's the right way. It'll still want to deform.
Oh, I see what you're saying.
That plastic's too thin.
When you're
I got you.
You can you're kind of checking to see where that band is.
Yeah.
The band starts pressing
Yes.
down.
Yep, I know what you're talking about.
You know what I mean?
Yep.
Can you guys come up with a better piece up there that's stronger?
We can. I can ask.
Okay.
Yeah.
And if you do that and the band comes down a little bit, are you like compromising the seal?
It maybe and maybe not. I've done it before. I did it one time when I was adjusting a door, and I didn't install the door. And so the door that had a latch lock on it that wasn't lining up right. And I thought, well, if I can just adjust the door up a little bit, it'll probably secure the door.
Right.
And so I got a screwdriver and just started turning that screw. And I was watching, and that IGU started dipping down in because the guy that installed it didn't turn
I've
it.
seen that plenty of times
Yeah.
too. But even when they are the right way, if the door has any kind of weight, those things just.
Yeah, I know what you're saying.
I've seen a guy before, like he'll take it out and he'll actually take like a plastic shim or something that's harder piece of wood
Yeah.
to get it over top of the two lights so it doesn't want
Yeah,
to smash.
that's a good solution to it.
It's a problem, dude.
Okay, I'll bring it up.
All right.
We'll talk more about that when we talk about doors. Okay. Yes, sir.
Going off of what he just said, I realized those clips he's talking about, like with your new thermal units that we're doing, they don't even really work.
Yeah, I just had that problem yesterday. That's why I was kind of concerned about that as well.
You mean you couldn't get it to adjust
Yeah, I couldn't get
Yeah, like there's really no adjustment for on thermal.
on the thermal doors? Why not? You mean you're turning the screw, but it's just not doing anything?
Yeah, there's just because of the way the brake is and the way that how close you have to fit that to the brake. There's like no adjustment on the drop. It's further
Okay.
down into the IGU itself.
All right. Well, you know that guy Ivan Zuniga that you guys met this morning? That's the kind of thing I talked to him about. So I'll try to grab him when I see him again. Okay. Those are good points. But back to the topic of storefront. We've talked about curtain walls. We've talked about doors. We're going to be here till midnight tonight. Okay? Anyway, so the next section of the book here is I call it the parts identification section, and it's got all your primary components: the mullion, the head, the horizontal sill, glass stop, sill flashing, and then it's got some other components: the heavy duty mullion, expansion mullions, things like that, adapters, corner mullions. Hey guys, please focus for me, okay? If you have a question or something, let me know. And then, of course, we've got all the different accessories, shear blocks if you need them, setting blocks, the flat fillers for the perimeter anchors, and then the water deflectors, side blocks, and all the different fasteners and so forth that we have as accessories, okay? Now, with regard to mullion cut lengths and the frame dimensions, that's going to be based on your rough opening dimension minus certain dimensions, okay? What we typically want for our rough opening or for our frame dimensions is you're going to measure horizontally at 3 locations, take the least of those dimensions, and reduce it by 3/8 of an inch on both ends. So it's going to be rough opening minus 3/4 of an inch should be your overall frame dimension, width-wise. Okay? Height-wise, we're going to do the same thing, measuring at multiple locations, take the least of those dimensions, and we're going to deduct 3/8 of an inch for above the head, okay? And then 3/8 of an inch for underneath the sill flashing. So the vertical mullion is going to be cut to the length of the rough opening minus 3/8 above the head, minus 7/16 for the thickness of the sill flashing, minus 3/8 of an inch under the sill flashing. Okay? Yes.
When you're talking about the overall width of your frame,
Yes.
are you accounting for like the screws that screw in the end dams on the subsill?
Yes.
You are.
No, that does not include those screws.
That adds up. You know what I mean?
It does, but when you think about it, then what we're talking about right now is the rough opening dimension for the frame. The sill flashing is actually a little bit longer. And I don't know if you guys are using them, but we have flathead screws that we're using on the end dams. Okay? But even with that, at 3/8 of an inch, you should have plenty of room to get those in.
Yeah, if you have room.
If you have room. But that's what I was talking about, the guaranteed opening dimension and why that's critical.
We have to lose those screws sometimes.
Yeah,
Well-
the screws will add like an 1/8 inch on each side.
If you're using with the flatheads,
Using flat.
But they're not counter. I think they usually make themselves self-supporting.
well, if you're continually running into problems like that, one other option that you have is instead of having a minimum 3/8 inch perimeter caulk joint, that's a minimum dimension. It can be more than that. You can have 1/2 inch perimeter caulk joints. The problem becomes when you get much larger than that and getting the caulking to stay in place while it's curing. You ever run a caulk bead? You come back the next day and the caulking's all laying in a puddle on the floor. Okay, especially when you have very large caulk joints. So you can make them bigger if you want to. We make the sill flashing longer than the frame width so that you can set the frame in and not bump the end dams off. If you've got to remove the fasteners from the end dams, then to get the frame to fit, then you got to do it. Okay, but there's a reason that we have them fastened, because the outside of the end dam is going to be fastened to, or is not going to be fastened. It's going to be sealed to the substrate, and so when that sill flashing expands and contracts, what we don't want to have happen is we don't want the end dams pulled off of the sill flashing. Okay, so kind of keep that in mind too. Best if you can find a way to keep those fasteners in there and still get the frame to fit in. Okay. Okay, so why 3/8 of an inch? Is that a magic number?
Yeah.
It is. It's not a magic number for us. I really don't care. It doesn't matter to us what size the perimeter caulk joint is. Where we come up with that number is from people like Tremco and Dow Corning. Okay, because your perimeter caulk joint is a dynamic joint. That means it has to be able to move. Your aluminum is going to expand and contract due to changes in temperature. The concrete is going to change due to changes in temperature. Everything expands and contracts. Aluminum expands and contracts a lot. And so you have to have your sealant installed in a manner to allow the sealant to flex when you get that movement. That's why we don't bed our flashing in sealant. Okay, we shim it up, we put backer rods under there, and we put a proper caulk bead. That way when you get movement, it can stretch. Okay? Any questions about that? So again, I get phone calls, from general contractors. Hey, your installation instructions say that they got to have a 3/8 inch caulk joint, and they only have an 1/8 inch caulk joint. Is that okay? I said, you got to ask Dow Corning and Tremco. I can tell you they're not going to like it. Okay, that's where we get that number from, is from them. Okay. Also, if you have a frame, the width of the frame is over 24 feet, you need to have expansion mullions every 12 to 15 feet. Okay? Expansion mullions every 12. Why do you need expansion mullions?
For if it doesn't have that, you won't get the guarantee.
Well, yeah, if you have a long run of storefront and you don't have expansion mullions, well, the thing is, your typical storefront application. Hey, Larry Bird, did you take your sunglasses off? Are your eyes okay?
Yeah, no, the TV print's small. I can't see it.
Oh, then go ahead and put them back on. I'm sorry. It was just, I was like, what the hell's he doing? Is he sleeping there? Anyway, that was a trick back in the day. So when you look at a typical storefront application, let's talk about what typical means for just a second. What would be a typical storefront application? How tall?
8 feet.
8 feet, 10 feet, maybe 12 feet. 12 feet would be a pretty tall storefront, but that would be typical. What about width from vertical to vertical?
24 feet.
No, vertical to vertical. How far is it between vertical mullions?
Say 50 inches.
Okay, 4 feet, 5 feet, maybe 6 feet. Okay, so the horizontals in that. So you got a long run of storefront. Okay, like let's say this wall is all storefront right here, and it's facing the south, and it's bronze anodized, and you got a door in here, and you got an intermediate horizontal. But you got vertical. The horizontals are only about 4 feet long, right? So how much can they expand and contract? Well, each one of them. Oh, by the way, a 10-foot piece of aluminum will change in length by 5/32 of an inch in a 100-degree change in temperature. Okay, that's 10 feet, 5/32 of an inch. Okay, now is 100 degrees? Does that sound like a lot?
No.
Okay, it shouldn't, because I'm not talking about the ambient air temperature. I'm talking about the temperature of the aluminum itself. So you guys ever go outside on a sunny day in the summertime and try to pick up a piece of bronze anodized aluminum?
Yeah, that's easy.
Okay, or picked up the same piece of aluminum in the middle of the winter when it's 15 degrees outside? Okay, yeah, you have wind chill that cools the aluminum. It works like coils in a refrigerator, right? And then in the summertime, it heats up. So the aluminum is going to want to expand and contract. So what typically happens in a long run of storefront is one of two things, or one of three things, if not all three things that I've seen. Okay, again, let's assume for a second that we don't have an expansion mullion. So we know that when it gets cold outside, the horizontals are going to shrink. Okay, so that means each one of those horizontals is going to shrink a little bit. And that by itself isn't the problem. It's the cumulative effect of all of them shrinking. So what ends up happening is your perimeter caulk beads tear. Your mullions unsnap. That's when it gets cold, okay? When it gets hot and they want to get longer, think about your door here for a second. You guys ever seen a door that binds? It doesn't want to close and doesn't want to open when it gets hot? That's because the horizontals are growing. Okay, and they can't grow into the wall because there's structure down there, right? So they're going to grow in this direction, and typically what they do is they cause the door jambs to bow in, and it causes the doors to bind. Or it can cause your securing hardware not to want to line up and secure the door. So that's why when we have these long runs of storefront, we need to have the expansion mullions every 12 to 15 feet, okay? And we'll talk about the expansion mullions here in a little bit. Okay? You guys ever install the receptors?
Yes.
Head receptors like this?
I love them.
Yeah.
You love them? Is it a common thing for you guys, or is it something you do just once in a while?
10%.
10%? Yeah, that, by the way, that's something that I'm seeing growing in popularity for two reasons. One is, and the most common reason is because you don't like the guaranteed opening dimensions, right? So what this gives you is an extra 7/8 of an inch to play with no matter what, okay, which is good. The other reason they're becoming more popular is if you're installing your storefront underneath something structural that might move, and the architect anticipates that there's going to be movement, then again, we can use the receptors to accommodate the movement. How much movement do you get when you shim this? When you shim the head and anchor it to the top? Well, no, just the head mullion, not the receptor, just the head mullion. How much? You don't get any movement, right? But you use these receptors, and you've got, like it shows here, in the standard configuration, 7/8 of an inch to play with. So we've included that, the installation of the head receptor and what that does to your dimensioning in the event that you've got projects with the head receptors. Okay. After you've got your vertical mullions cut to length, did you have a question?
I did.
Yeah.
Do you also offer that on your operable windows, the head receptors?
We do. Yeah, that's very. It's much more common with windows. So typically with window installation, you'll have pannings. Okay, kind of like sill flashing that the window fits into, and then they'll use this receptor at the jambs and the heads, and that's just to simplify the. And what happens a lot of times with windows on a lot of window projects is you might have 100 windows and they're all the same size, right? And so, but the openings aren't all going to be the same size. So what we'll typically do is you have a choice. You can either give us 100 different dimensions, and we can make 100 different sized windows for you, or we can make them all the same size, and you could use these receptors for making up the differences.
Could you offer on the 400 sliders and the 600 sliders?
Receptors?
Yeah, the head receptors.
Not on the sliding doors.
Why is that? Because that's something we run into
Well, the problem,
Or retrofit
yeah,
stuff in.
yeah. The problem with the sliding door products is what happens when you have to, because those sliding door units are so big. When you operate them, the frame flexes so much that it can create problems if the frames themselves aren't anchored. So you could install them. You could, in theory, install the sliding door in a receptor like this, but you'd still have to shim it within the receptor. Okay. Same thing with the terrace doors. If you're installing those in receptors, because when you open that terrace door, the frame wants to flex. Again, you guys ever installed the terrace doors before with the multi-point locks? All those things have to line up, and when you open it, everything changes, and when you close it, it may not go back to the way it was before. Okay, so you just have to be thoughtful of all of that.
Is there any reason why you couldn't screw it from the inside to stabilize it?
You'd have to have a PE, an engineer do calculations on it to find out if it can take the motion. Okay.
Thank you.
Okay, so when on the vertical mullions, you guys have CNC equipment, right, for drilling the holes in the verticals? Is that correct? Out here in the shop? Okay. Or we have drill fixtures that can be used. You know, even in the field, it's probably a good idea for you to have the drill fixtures just in case, you know, in your toolbox. But at any rate, again, you can see here for outside glazing, inside glazing, where the locations, these are the layout locations for the holes that have to be drilled or punched in the vertical mullions for attachment of the screw splines to the framing system. Okay, and this is just showing kind of a blown up, highlighted view of the hole pattern that's going to be in this case in the vertical mullion or the jamb. At the head, they're even. At the intermediate horizontal and the sill, they're offset. And then for the pocket filler, the same thing. The whole locations. Okay? That's for attachment of your screw spline screws. All right? This is a fun one. Glass stops. So the horizontal mullions are going to be cut to a length of daylight opening, correct? Right? No, the mullions, the horizontal mullions.
Yes.
Okay, the glass stops, we want you to cut to a length of daylight opening minus a 32nd of an inch. Why are we cutting those short like that? Yeah, so when you go to rotate them in, they're not rubbing against the verticals and damaging the finish or making it difficult and time consuming for you to put those on. Okay, that's what we're trying to avoid there. You know, here's the thing about this. The phone call that I usually get about that is guys are cutting them a 16th of an inch short instead of a 32nd of an inch short. Now, is there necessarily a big performance problem with the system if you cut them a 16th or a 32nd? Probably not. Okay, but it becomes an aesthetic thing for the architect. And what I tend to see what I see happen over and over again, the guys cut them a 16th of an inch short. And by the way, you know, if they call me about it, I got to say, look, our instructions say DLO minus a 32nd of an inch. And then you guys cut them a 16th of an inch or more than that. Hell, I've seen pictures where they're cut an 1/8 of an inch short. And they look like they were cut with a chainsaw because they're using a chop saw in the field and they haven't sharpened the chop saw blade in 4 years. Okay? So what usually happens, a customer will call me up and say, hey, Bart, I got this nitpicky ass architect. We cut the glass stops a 16th of an inch instead of a 32nd of an inch. Would you please write him a letter and tell him to love this? And I can write all the letters you want, but I can't make the architect like it. What he's looking at is he's looking at this right here, and that's what he wants. But what happens is, what typically happens, and I'm not talking even in this case about what usually happens is the customer sends me that, and I talk to the architect. He goes, oh yeah, well let me show you what he did. And then the architect sends me the pictures where it's an 1/8 of an inch short, and it looks like it was cut with a chainsaw. Okay, so that's the back and forth I'm getting, you know, from the architects. But the bottom line is if you do cut them a 16th of an inch short instead of a 32nd of an inch short, God bless you, okay? But what you want to do is snap them in to where you got an even gap on both ends. If you do that, they won't even probably notice. What they're seeing is they're seeing a hairline joint on one side and a big 16th of an inch gap on the other side. So it becomes more of a workmanship thing than it is a product performance thing. Okay? So just be, again, I'm just sharing information with you. You can do what you want with it, but that's what we call out in here. When the architect sees that and you do something else, he's going to question it. Okay? And I really don't like getting in the middle of these workmanship arguments. It's uncomfortable for me. Okay? If you're right, if you cut it a 32nd of an inch short and the architect goes, I don't like that, I'll say, go to hell. We got to have, it's not possible for them. It's not, if they cut the glass stops to daylight opening, then you're not going to like the scratches in the finish. So there you have it. Okay. So yeah, if you're gonna have an argument like that, be on the right side of it for me. Okay. The sill fabrication. The sill mullion is cut the same length as the horizontal. That's the daylight opening dimension. Okay. Now, the way that we attach our sill to the sill flashing is through this little channel right here in the front of the sill. You guys see that? Okay. What that's for, what this channel is for, is so after you've set the frame in the sill flashing, we have a little stainless steel screw that you're going to run through the sill to attach it to the sill flashing. And this screw does not penetrate the sill flashing. You guys remember in the old days, they used to, after you set the sill in here, they'd make you drill a hole through the sill, drill a hole through the sill flashing, then drill down into the concrete, pump a bunch of sealant in here, and hope and pray that that screw got sealed up, right? And you guys didn't like that, so what did you do? You screwed through the back of the sill flashing, didn't you? Go ahead, own up to it. Yeah, I know you did it. I've seen it.
It works.
Okay? It works, except that screw's underwater. During a wind and rain event, the screws get rusty and they leak. And not only that, the purpose of these screws, this one or this one or this one, is to manage something called an end reaction. Who knows what an end reaction is? Do you guys know what deflection is? Okay, so when you have a storefront system or a curtain wall system for that matter, when the wind blows, the glass catches the wind like a sail on a sailboat, and it transfers the load of the wind to the mullions. Okay, like the mullions would be like the mast on the sailboat. Well, when the load gets transferred to the mullions might want to deflect a little bit in reaction to that wind. Okay, and there is an allowable amount of deflection. It's a ratio. It's L over 175 that we allow those mullions to bend. Okay. Now imagine in your mind's eye for a second, we got some sawhorses sitting right here, and we've got an aluminum mullion or a 2x4 sitting on the sawhorses, and I push down on the middle of that mullion. Okay. It's going to deflect, right? What happens at the ends? They react in the opposite direction. Okay. So what happens, the reason that we have to have these anchors here is because when your vertical mullion is deflecting, the ends of the mullion are wanting to react in the outward direction. So without any fasteners here, what's this going to want to do?
Pop out.
It's going to want to pop out. Okay? And so we control that either by anchoring this down to the frame. So now if you're just running a little number 10 screw through the back of that sill flashing, do you think those threads are going to be able to manage that end reaction? Okay, what's likely to happen is in addition to the screw rusting and leaking, the threads it'll either cause dimpling back here or it will just fail. Okay, we do have a little lip out here in the front of the sill flashing to manage some of the end reaction, but the way that we do it is instead of penetrating everything and creating potential leak locations, we attach the sill to the sill flashing in this manner right here. Does that make sense to everybody? So the fabrication of the sill consists of cutting it to size and then drilling holes for this screw to go through. 6 inches from the ends and then no more than 24 inches on center in between. Okay? And then when you get the frames, those holes should be drilled and you set them in the sill flashing. And when we get to the installation aspect of this, you're just running those little stainless steel fasteners down there. The stainless steel fasteners are a pain in the ass because they're not magnetic and all that stuff. But the reason we have to make them out of stainless steel is anytime we have a fastener that we believe could be immersed in water for a period of time, we want to make sure they're made out of stainless steel. So what can happen during a wind and rain event is you might get some water sitting on this screw. Now, if you notice down here, there's a little lip right here that kind of raises the head of the screw up. That's so that any water that gets in here can go through the screw, come down to the flashing, and drain out. So one thing, you don't ever want to seal these screws. Okay? Those screws are just there for managing the end reaction. My big fear is somebody's not going to be able to find that screw. They're going to get longer screws. They're going to drill a hole in the sill flashing, and we're going to be off to the races. Okay? That's bad. Okay? So make sure you got the right fasteners. Okay? Any questions about that? Okay? The sill flashing fabrication. So the sill flashing, the cut length of the sill flashing is going to be frame width plus 1/8 of an inch at the jam conditions. Okay? So if you have frame width plus 1/8 of an inch at the jam conditions. Okay? Now how is it from the back, how far is it from the back of the jam to the wall? Do you guys remember? 3/8. So the sill flashing is 1/8 of an inch longer. That still leaves you 1/4 of an inch between the end of the sill flashing for those fastener heads. Okay, that's the way, that's what it's designed for, that way. Okay, so you're going to have an extra 1/8 of an inch at the jam conditions, and again, that extra 1/8 of an inch is so you're not trying to set that frame down on top of the end dams. You want to have room to wiggle that frame into place. Okay, of course, at door jam conditions, you're going to be tight to the back side of the door jam, and the door jam does not sit on the sill flashing. The door jam, when we talk about doors, the door jam has to sit down hard on the ground. Okay. So we cut the sill flashing to rough frame opening width plus 1/8 of an inch at jam conditions, and then we need to drill weep holes in the sill flashing. Okay. Two key things about the weep holes are the location of the weep holes and the size of the weep holes. Who can tell me what size the weep holes need to be?
5/16.
Yeah, that's a critical number, okay? And the reason is, and I'll take you back in time, back to when I was a fabricator. We weren't allowed to drill round weep holes. Every weep that we had to create had to be slotted. You guys ever see old windows with slotted weep holes? Do you know why? Do you know why they wanted slotted weep holes?
Better drainage characteristics for driving rain and winds.
That you're exactly correct, and the reason for that is because the most common cause of leaks with round weep holes is when you get a bubble. Okay, during driving winds and rains, you get the fluctuation in pressure. You get a bubble over the weep hole, and when your weep holes are real small, the surface tension on the bubble is strong enough to prevent the water from draining out. Okay, so we used to have to do slots because slots are elongated and bubbles do not want to be that shape. Bubbles want to be round, so you don't get a bubble over a slot. However, from a fabrication standpoint, it's a hell of a lot easier to fabricate a round hole than it is a slot. Okay, and so, and again, I'm not a hydrodynamic engineer by any stretch of the imagination, but the way it works out is if your weep hole is 1/4 of an inch or smaller, the surface tension on the bubble is strong enough to prevent water from draining out. What will happen is your sill flashing will fill up with water and overflow. It'll overflow the end dams, water will come up through your gaskets at the sill, that whole thing. You make the weep hole just a little bit bigger, 5/16 of an inch. The weight of the water is strong enough to break the surface tension on that bigger bubble, and then the system can drain properly. Okay, so that's item number one. Is when we talk about drilling weep holes, and you'll hear this repeated when we talk about curtain wall fabrication, is we want the weep holes to be round, and we want them to be 5/16 of an inch. In the case of the sill flashing weep holes, they're going to be drilled up here in the front. Remember this little channel where we have that anchor screw? You're going to drill the weep holes, 2 per daylight opening, located at quarter points of the daylight opening, okay? And I'll tell you what I've been finding recently, but looking at the storefront from the front, this is sort of an elevation view of the storefront right here at the bottom. So this is here's the wall, here's our jam mullion, and here's our next vertical mullion. the weep holes, we don't want the weep holes to be directly underneath the vertical mullions. We want them to be at quarter points of the daylight opening, okay? And the reason that that's important is because during a wind and rain event or during a field water test, you might actually be sucking air in through these weep holes. And at the storefront frame, if you have that weep hole directly underneath the jam mullion, the air that's getting sucked up when the sill flashing fills up with water, it causes that water to percolate, right? Imagine an air hose at the bottom pulling in air and it's full of water. It's going to percolate. And what ends up happening is it splashes over the end dams. Okay? So I've run into a lot of projects where the guys are putting the weep holes at the bottom of the vertical mullion. And I know why they're doing it. In logic, they're thinking, okay, the water runs down the vertical mullions, bang, let's put the weep holes right there. Okay? You don't do that though. Put them at quarter points of the daylight opening. And again, that's for typical applications. Okay? If you have 10 feet between vertical mullions, you may want to look at adding an extra weep hole in there. Okay? Or at least asking about it. All right? Any questions about that? Okay. Okay, we talked about the use of the expansion mullions, right? Remember the rule. If your storefront run is over 24 feet, you need to have an expansion mullion every 12 to 15 feet. We have the same rule for your sill flashing. If your sill flashing is over 24 feet long, if it's 24 feet or less, you don't need to have any splices. If it's over 24 feet, you need to splice the sill flashing every 12 to 15 feet. And the proper splice should have about a 3/8 inch space. So what we don't want you to do is to have a hairline joint splice. We need to have the space to allow the sill flashing to expand and contract. Okay? So you need to leave a little bit of a gap, about 3/8 of an inch, where you have the splice. The other thing is, do not locate the splice directly underneath the vertical mullion. Okay? Put the splice, somewhere in the daylight opening area. We say to put it at the center of a daylight opening. It doesn't have to be directly at the center. What we just want to avoid is having the end of the vertical mullion sitting on the splice sleeve. Okay? And the reason for that is because our splice sleeves are made out of silicone. Have you guys seen our splice sleeve material? So the actual sleeve material itself is sort of an opaque, it's cured silicone sheet is what it is. It's smooth on one side and it's got ridges on the other side. And you're going to put sealant on both sides of this joint and then bed that sleeve down into the sealant. The problem becomes if you put a vertical mullion directly on top of it, think about what happens to aluminum when you cut it, how sharp it is. And you put that directly on the silicone and on the splice sleeve, and then you start putting glass in and all that weight is digging into it, you're probably going to cut the silicone and cause it to leak. So that's why we want the splice joints to be somewhere near the midpoint of a DLO. But it doesn't have to be exactly there, just so long as it's not directly underneath the vertical mullion. Okay? And again, the note. If your opening is over 24 feet, you need to splice it every 12 to 15 feet. So think about that for just a second. So if you have an opening that's 30 feet long, is it okay to splice a 24-foot piece to a 6-foot piece? No. Okay, so if you have a 30-foot opening, you need to splice it at 15 because that 24-foot piece is going to want to expand and contract more than that joint can bear. Okay? So again, if you have a run over 24 feet, you should have no more than 12 to 15 feet between splice joints. Okay?
I've seen a couple times inspecting jobs of leaking problems.
Yes.
They'll have a partial shaded area, and then a full sun area.
Yeah.
We find a lot of problems.
And because they expand and contract at different rates. Yeah. And that's why we have the 3/8 of an inch instead of a hairline joint. Okay? And again, I know that you're thinking that flashing is going to look better if you butt it together, but it will probably, especially if you've got everything installed level, it's going to look probably better. But remember, the purpose of it is it's got to be able to accommodate movement. And so if you do leave that 3/8 of an inch space there, if the architect or the general contractor complains about it, hey, can't this be a hairline joint? Remind them about thermal expansion. Okay, they know that. They know that there's going to be expansion and contraction. Sometimes they just kind of forget about it. Okay, and the other thing too is you'll see after we get the frame installed, it's going to be necessary for you to caulk the ends of the flashings together at that 3/8 of an inch on the interior side. You're going to need to caulk it. You know, try to pick a color caulk that works with the color of the aluminum. So if you got clear anodized aluminum, don't use black silicone there, okay? So, you know, if of course now you may have painted jobs or whatever, but if you're using clear anodized aluminum, they have silicone that comes in a color that very nearly matches that color. Bronze, the same thing. Black, the same thing. They have silicone in those colors. Now, if you get into fancy painted colors, blues and things like that, well, obviously silicone doesn't come in every color. Maybe you give the architect a choice, or try to pick a color that doesn't jump out at them. Okay, but we got to have that space for accommodating the movement. Okay. Any other questions about that?
Yeah. Is there a? All right. So I'm just saying this because I've seen it done different ways on a splice. Bridge side up.
That's a good question. No, it's going to be so. We'll get to the part. Let's address that when we get to the part where we're actually putting the sleeve in there, because that's coming up. Okay, I know the question you're asking. Okay, so this is the other thing too. Okay, this type of thing. This is the attention to detail that you have to have, because these are things that you know, you can come to my training and I'll tell you this, and maybe there's like 4 or 5 different things on here. And maybe you'll remember 2 or 3 of them, okay? And maybe the next time you come, you'll remember the other ones. But these are commonly causes for leaks if they're not done properly. So when you go to assemble the frames, and I'm assuming you're assembling the frames here in the shop, correct? Who works here assembling frames? So you're buttering the frames when you put them together, correct? Putting sealant on them. No? Okay. This is what I'm talking about, okay? Which, hey, don't listen, this isn't about, I'm not judging anybody, okay? This is why we have training. So when you screw spline these frames together, okay? The screw spline joint, would you describe that as a super tight joint? I would. It's tight, right? When you run those screws in and you're screwing the verticals to the horizontals, that's a very tight joint. But it's still a metal-to-metal joint, and it's not airtight and watertight. And so what we're showing you here on page 14 are the areas of the mullions, the horizontal mullions and the vertical mullions, where you need to apply sealant as you're assembling the frames. So if you guys aren't doing this in the shop, then you need to be doing it. You know, and I could talk to Matt about it. Yes.
I think we need to have the people that are actually putting those frames together up here for that.
Well,
they're all down there putting frames together.
Understood. I got one of them sitting right here. Okay, but just look at what I'm showing you here first. Okay, this is what should be happening. So first of all, you guys have a saw out here, correct? Does the saw have lubricant like a spray mist or something like that? Do you think when that dries on the aluminum that the sealant is going to stick to it? Okay, so number one is whenever you apply sealant onto something, you have to clean it first. And typically, if you're using silicone sealant, you're going to want to wipe it down with isopropyl alcohol. Okay, if you're using polyurethane sealants, then maybe you use mineral spirits or something like that. But typically for silicone, it's going to be isopropyl alcohol. Now at the head, what some people will do is they'll apply sealant to the entire profile of the head mullion, which you can do that if you want to. At the very least, you need to do it at these areas where we're showing it highlighted in your installation instructions, which is the areas typically right around where the screw spline is. Can you see that? Can you guys see that on these details up here? At the very least, you need to apply it here on the horizontal here, and also look at what we're doing here with the horizontal. You see that backer rod right there? That's not running the full length of the horizontal. What we want you to have is a small piece of backer rod that you're going to stuff in at the ends of the horizontal only and you're going to put a skin of silicone over that backer rod. Do you follow what I'm saying? Okay. And yeah, I know. Okay. But here's why you have to have that. All right. We have water deflectors that are going on the ends of the horizontals, and the water is supposed to drip off the ends of the water deflectors. Okay. And we'll talk about the water deflectors here in a little bit. But when you're doing a water test or during a wind and rain event where you have high air pressure outside and low air pressure inside, sometimes what will end up happening is that water that's supposed to be dripping off the end of the water deflector gets sucked in right here and ends up back here in the back of the horizontal, and then it drips down the side of the vertical mullion as a leak. So we put these little pieces of backer rod only at the ends of the horizontals and then just put a skin over them, okay, to prevent that water from getting sucked into that hole right there, okay? And then, of course, here at the sill, you can see where we're applying sealant as well. And that's, again, for controlling air and water during a wind and rain event or during a test, okay? Also, in the vertical mullions and the pocket fillers, you see what we're doing here? At the head, at the intermediate horizontal, and the sill, right? Okay, so for example, again, the same thing. When you have water and it's dripping off the end, we want the water to drip off the end of the water deflector only. We don't want it running down these reglets. If it runs down this reglet, it's going to get on top of that gasket underneath it. It's going to build up, and it's going to come under the underside of the horizontal and get on top of your IGUs. Remember what we said about getting water on top of the IGUs? If the water's on top of the IGUs, we don't have any control over it. You get leaks, you get fogged up IGUs. Remember, we want all the water going off the ends of the water deflectors and down to the sill flashing. Yes?
If that's not being done, does it void the warranty?
That's a good question. So I get that question all the time. First of all, our warranty, if you read it, which I've had to do, is that our product is free from defect as manufactured. That's by us. Okay? Do these steps have anything to do with us?
No.
What it does is it voids your warranty. Okay, so we're responsible for the quality of the material. We're providing you with material that has the potential to perform. Okay? It's up to you guys to make sure that all of these steps are followed so that it can perform. Okay? Now, unfortunately, that doesn't void your warranty either. That is a warranty remediation problem for your company. And that's why you don't want me coming to your job sites when you get leaks. And the reason I'm telling you all this is because this is the stuff that I find when I go to job sites. We put it right here for you in the installation instructions, and then you can either do it or not do it, right? But if you don't do it, and I come out and I go, look, you guys, I'm sorry, we need you to do this, and we need you to do this, and we need you to do all of these things. If you've got glass installed, how easy is it to do all this? You're screwed, aren't you?
Yeah.
Right? That's why you don't ever want to see me again after today, because that's all I do. Okay? That's all I do. Now, on the other hand, if you're trying to snap our stuff together and it's not snapping together, or you want to put the gaskets in and they're not tight and they're falling out, hell, we might have a problem. But if you're getting everything put in and it's all snug and tight and you're having leaks, it's usually because of this stuff right here. Okay?
Was this one of your adjustments in 2024?
No, sir. It has always been. It has always been like this. Hey, listen, the Conair installation instructions look the same. So do the Old Castle. These are all of these storefront systems. There may be subtle things that are different from one brand to another, but all of this stuff is the same. We all use water deflectors. We all use end dams. We all seal joints. We all use gaskets and seal the ends of it. All of that stuff is common from one to another.
Well, I'm just doing it from a standpoint of the company expecting a certain amount of work getting done. And if they knew about this, that's going to slow a lot of stuff down out there.
Understood. Hey, listen, I understand. That's not my thing.
Yeah, I get it.
My thing is making sure that you guys understand this. And if one of you wants to sit down with Matt after this is over, or Siggy or somebody, and go, hey guys, we need to talk about a couple of things. But believe me, they know. Okay, Matt has been to this training. Joe Trivellini has been.
Problem is, they're not the ones that are.
I understand that. But they're the ones that are responsible for making sure it gets done ultimately. Okay, and those kinds of discussions are labor management discussions. Yeah. I'm just here giving you information. But hopefully, here's what I hope you take away from this is, first of all, recognizing that these things need to be done, not just because I say so, but because that's how these systems work. What we do is we design these systems and then we test them. And if they leak when we test them, we go, well, why the hell is it leaking? And then that's where these types of things come in. We don't just have some guy going, hey, let's throw some sealant in there. Usually if there's failures involved, and then we find that when we do all of these things, we pass the tests every time. Okay? Sometimes you can not do this and it'll pass a test. Maybe, say you test it 10 times. Maybe it passes 4 times, but it's going to fail 6 times. Okay? So that's how all of the, and that's what I want. I need you to leave here understanding that. Okay? Not just, hey, the guy said we have to do this, so now there's some extra work we got to do. We got to buy more sealant. I mean, that's South Jersey glass issues. I'm just trying to give you guys the best information I can to make you be able to, to help you be able to do your jobs as best you can. Okay? And I get it. Yes, sir.
So for that, putting caulk on that or sealing or whatever, for like side lights for door frames and stuff like that, would it have the same thing? You would have to.
Oh yeah, side lights too. Now, are storefront doors waterproof? No, they're not. But we don't want water from the side lights leaking in. Okay, so yeah, that would apply to anything that's got glass in it. Yeah, because if it's got glass in it and still flashing underneath it, it's intended to be able to manage water. Now, if they've got getting water on the side lights, they're probably getting water on the doors too, and they're going to leak anyway. Okay. Same thing with the transoms. All right. But again, page 14. Highlight this, guys. This is really important stuff. Okay. And by the way, the field testing. How many of you guys have ever had field testing performed on your work? Anybody where they come out and they put up a test chamber and spray water on it and stuff? That's only getting more and more common. Okay, that's not going away. And so if you haven't had it done to your work before, it's an uncomfortable feeling to stand there and watch somebody scrutinize your work that way. Okay, it's kind of like what the government workers are going through right now with the new government inspection agency. A lot of these government workers have never had anybody saying, "Hey, what do you do all day, every day?" And that's damn uncomfortable for them, isn't it? Okay, it's going to be the same thing for you when they come out and they go, hey, we're going to hook up a test chamber and we're going to pull a vacuum from the inside and we're going to spray water on it from the outside for 15 minutes. And if it leaks, it's on you. Okay? So ideally, if you're doing all of this stuff right, you don't have leaks. That's the bottom line here. Yes, sir.
So why do you guys come up with? Because I know, like from my end, I've done a lot of residential also. Why didn't they come up with basically a foam pad that when you screwed it together would seal everything up to just mount on?
A what now?
It's a pad. It's actually
like a gasket, like a foam gasket. Yeah, the problem with that is the tolerances and how thick they are. And there have been a couple of guys that have tried to do that with storefront framing before. Part of the problem is the size of the foam pad and the amount of room that it takes up and the problems that are created by damming water up in areas. So how do you put a foam pad on the end of a horizontal without trapping water? How do you do it without creating a great big fat seam where the two of them come together that the architect doesn't like? But I've seen people do it, and it may ultimately be a good thing to do. But every time I've seen somebody try to do it, the glazers just say, "Fuck this! Give me my caulk gun." So the gaskets themselves tend to be more labor than just applying sealant. And I'm sorry for the language there, guys. Anyway, so you were asking if any of this was oops. You were asking if any of this was recently changed, and the answer is no. This has all been the same for a long time. So one of the recent changes was this right here. So we've had projects. So what you're seeing here, and this is something that was changed less than a year ago. When you run your perimeter caulk view, first of all, what you're looking at here is an isometric view. You're looking at from above the head. Okay, so this is the head mullion. Here's your the top of your pocket filler. Here's the top of the female mullion right here. When you run your perimeter caulk bead across the top, that caulk bead is running right along here, right? The same thing. This is on the outside, and this is on the inside up here. The problem becomes when you get to the end of the vertical mullion, what have you got for the sealant to stick to? Nothing. So what's happened is, and typically with storefront systems, that hasn't been a problem because we're up at the very top of the storefront system, generally speaking, you don't get a lot of water blowing up in there, okay? But still, we get building envelope consultants and architects that go, hey, so what's supposed to happen to the caulk bead right here? And we've had some competitors come out with like mullion end caps for their storefront systems. And what we've always had for our window wall systems is this, it's like a foam tape. It comes in big long rolls, and you can just cut it and just stick it in up here, and all that's for is to create a good surface for your perimeter caulk bead. Okay? So we list this as an optional. The mullion end cap thing is an option. So if you get an architect that insists that something's done, we have a solution for it. Okay? And of course, that's only going to be done if you have a perimeter caulk bead running along here. If you have the two-piece receptor above the framing system, then you don't need these. Okay? Everybody understand what that's for? Okay? I think it's a good idea, but again, a lot of times the way storefronts installed right now, you're going to have a 4 or 5 foot soffit on top above that storefront anyway, and you're just not going to get water up there. So the durability of this perimeter caulk bead at the head, how important is it? Well, again, if they expect it to perform for 20 years, it can be a big deal. Okay? So the end dams on the sill flashing. The end dams, again, have that metal tab on them. The metal tab should be bent with pliers like it's showing in this diagram right here. The end dams are not handed. There's not a left-hand end dam or a right-hand end dam. But when you bend that tab, you're handing it. So if you bend it in the fashion shown in this diagram right here, it's a left-hand end dam. If you bend that tab back the other way, it becomes a right-hand end dam. Okay? The end dams come already cut to size with the attachment holes in them. So when you're ready to install the end dam, and do you put the end dams on the sill flashing here? Yeah. You do that here? Okay. So what you're going to do is, again, clean the end of the sill flashing, apply sealant to the profile of the extrusion at the end, slide the end dam tab in here, and then use these fasteners to mechanically attach it to the sill flashing, and then tool some sealant. Gun some sealant on the inside and tool it in. And if you're doing that in the shop, don't put too much sealant on there, because sometimes the guys put too much sealant on here, and when the guys in the field go to set the frame won't go all the way down because there's too much sealant here. And so what they end up doing is cutting that sealant off in the field. And if they're doing it in the field, they're probably doing it quick, fast, and in a hurry, and they might be cutting the seal. Okay? So make sure you're kind of being thoughtful about how much sealant you're putting. I honestly deal with more problems with guys using too much sealant than I do not sealing at all. Okay? That's true for water deflectors, joint plugs, and curtain walls, all that stuff. Okay?
Do you think it's a good thing to apply that in the field or in the back?
I think definitely in the shop.
Because I know I've seen our installers put, we put another bead on top of that before we set the frame in.
Another bead on top of what? On top of this?
The cured one on.
Well, again, that can be done in the shop. I don't think that there's necessarily anything wrong with it being done in the field. except that, if it should be done in the shop, it shouldn't be done in the shop and then also done in the field. You know what I mean?
Yeah.
And then two, I don't know how your company is structured, but usually most companies want as much labor done in the shop as they can get done, as opposed to doing it in the field, because labor rates vary. Especially like the glass company that I worked for, when I was a fabricator, I was a non-union fabricator, and our guys in the field were union glazers. And so they were paying me a lot less per hour than they were paying the guys in the field. So if I didn't seal something and they had to do it in the field, it was costing the company more money because they were doing it in the field with field labor, or drilling weep holes, or applying, the things that you can do in the shop should be done in the shop. The problem with doing it in the field, in addition to labor rates maybe being different, and I'm not asking or anything, but I'm going to assume that different people earn different money, and that field guys might typically earn more than shop guys, but I might be wrong about that. But the other thing too is it's important that be sealed properly, and that means clean without a bunch of frost on it or dew on it, or construction debris, sheetrock dust, anything that's going to impact the integrity of that seal. That's why it's always better to have it done in the shop, okay? And that's kind of a universal thing. And that's why the industry is moving more towards pre-glazing and unitization as ultimately probably the end game on this. Okay? That's a good question. What about this? How much does a tube of silicone cost these days? Anybody know? I mean, hell, there's an end dam. There's an end dam made with Dow 795. That probably cost $25 just for the sealant, right? And it didn't work, or I wouldn't have been out looking at it. Okay? So the sill flashing installation, sill flashing needs to be shimmed up a minimum of how much? 3/8. But the important thing is that it be completely level. Now, if you guys ever run into a condition where you put your shims down there and you've shimmed it up 3/8, as you move along, that caulk joints might grow, right? So is a 1/2 inch caulk joint okay? Is a 3/4 inch caulk joint okay? Is a 1 inch caulk joint okay? I don't care. It's not. All I care about is that the flashing is level. Okay. The size of the caulk joint ends up being an issue between you and the general contractor and the architect, because if you install it and you've got a great big fat caulk joint and the architect comes out and has a heart attack, then you got problems you got to deal with, right? So my advice is to kind of bearing in mind that we need to have it installed level. When you start getting into these excessively large caulk joints, probably a good idea to bring it up to the general contractor. Okay, that way, if he says, "Yep, go ahead and do it," then he can be blamed if the architect doesn't like it. Okay, so again, unfortunately, you'll probably want to get something like that in writing, because otherwise the architect's going to come out and complain about it. And I said, "Well, I told the general contractor, oh, you never said shit." It's like that. So, at any rate, we just want it installed level. Okay. And then two, as far as the fasteners for attaching the sill flashing to the substrate, when you look at our sill flashing extrusion, you might be able to see them in this detail here, but if not, you can see them in real life. There's something we call a V groove right there. Can you see it? Okay. There's another one up here. Whenever you see a V groove in one of our extrusions, we call it a V groove because it's sort of shaped like a V. But it's not like a die line, in the finish or the extrusion. It's something you can literally feel it with your thumbnail, okay? And so that's intended to be a center line for drilling a hole for a fastener, typically. Okay, that's what they're there to help you be able to do that. So when you're anchoring the sill flashing down, you can anchor it at either or both of those locations, okay? So again, we show the anchor here. Sometimes what I see guys do is they'll go back and forth. They'll do some up here. They'll kind of zigzag it as they go along. It doesn't matter to me how you do it, as long as it's meeting, a requirement that we have for anchoring the flashing down. And then, of course, when you drill down into the concrete, what comes up? And so, you think that sealant's going to stick real well to that dust? No. So we got to make sure that we, blow it off and then wipe it off with a rag with some type of cleaner on it to get that off, so that when we seal the screw head down, we're getting a good seal. So the question was asked earlier about applying the splice sleeve. So this is a diagram showing at the splice joint. Okay. Another feature that you'll notice on the sill flashing is this little, we call it a nub. You see this little nub back here? Does anybody know what that's for? It actually serves a purpose.
For wicking the water, so you want a wick break.
Good guess, but wrong.
So you don't get that conduction of the metal?
Nope.
Doesn't that fit into like another piece that silk can sit on?
And no, not really. What all it's for? Have you ever seen where you've got sill flashing and you've got a splice sleeve, and the sill is running along nice and even with the top of the flashing, and then when you get to the sleeve, what happens? It raises up. Okay, it raises up by the thickness of the splice sleeve. So what we do is we put this nub down here. Guess how thick that nub is? It's exactly the same thickness as that splice sleeve. Okay, so the idea is where you have a splice joint, you relieve the nub on both sides of the splice joint. Yeah, so you can use a grinder, or even you could probably even knock it off with a chisel. Okay, to an inch and a half on either side. Then you lay your sealant down in here. Then your sleeve comes down, and so what you end up with is the splice sleeve fitting in here without causing the sill to raise up. Does that make sense to everybody? Okay. Obviously, it's not the end of the world if it does raise up, but the idea is to have it be more aesthetically pleasing to the architect and the building owner. Okay, that's what that's for. Okay. So what you're going to do after you relieve the nub is you lay your silicone sealant down in here, like it shows in the diagram, and then the splice sleeves, they come. Do you buy our splice sleeves? They come in the package already cut size.
Yeah.
Okay. They're still probably going to need to be trimmed. Okay. So you're going to because we have different size flashings and these, so it's going to need to be trimmed. But it's smooth on one side and it's ribbed on the other side. You know why it's ribbed? For her pleasure, exactly. No. What it's ribbed, the reason it's ribbed is because when we lay the splice sleeve down in, we want the ribbed side going down into the sealant. And the reason for that is it's going to take a while for the liquid silicone to bond with the cured silicone. Okay? And if there gets to be movement during the curing process, the ribs help keep the silicone sheet locked into the liquid. Okay? So the rib side goes down for the silicone's pleasure. All right? And that's what it's for. Okay? Any questions about that? Here's a good one for you. You guys will love this if you don't already know. How would you describe the shape of our screw splines? Kind of a diamond? Yeah?
Yeah.
Have you ever seen our competitors? They're round. You ever wonder about that? He says more grip.
Less likely for the screw to strip out.
Less likely for the screw to strip out. Not so much. Anybody? Come on, you guys don't know? Electrolysis again? No, not that. It's not for her pleasure. Okay. Okay, when you're assembling the frames, when you're screw splining the frames together, what do you do to the screws before you run them in?
Wax them.
Wax them. Why do you wax them?
Less friction.
Less friction. So sort of. You're right. What's happening is when you run spline screws into a screw spline, you're tapping it, right? You guys know what tapping is, right? So that screw is literally tapping the inside of the screw spline. And as it's doing it, it's cutting threads. And the threads are the aluminum that's being shaved off by the screw as you're screwing it in. When you have a round screw spline, what happens is those the threads that you're cutting build up on the threads of the screw, and then eventually what happens is the screw binds and the head snaps off, right? Then you're going to get your vice grips to back it back out and run another screw in. So at YKK, our screw splines have this diamond shape so that you don't need to lubricate the screws. The idea, remember the stick wax and you sticking all the screws in there? Shit, I'm out of wax. I got to get another piece of. Well, you don't have to do that with our material. And the reason is because of the shape of this. The points of that diamond are areas where they allow the thread cuttings to build up so that the screw doesn't bind. So all of your guesses were good, and in a way they were all accurate. But there's a specific reason for why they're shaped that way. And you'll notice even where you attach the end dam, all of our screw splines will have that distinctive shape. The idea being that you don't need to use wax. So here's what you can do in the fab shop. You can get rid of the wax and get some silicone down there for caulking your frames when you put them together. Okay? Any questions about that? Okay? Just about. Okay? So this is what your properly installed sill flashing looks like. We got our end dams nice and sealed up. We got our fastener holes sealed. We got our splices sealed up. Everything's shimmed up, and we're good to go. At your splice joints, you're probably going to want to put a piece of bond breaker tape. Guys, give me just a couple minutes here. We'll take a break. Put a piece of bond breaker tape on the back of the sill, right at this location here. Okay? Does anybody know what that bond breaker tape is for? Well, what is bond breaker tape used for? Anybody? Yeah, when there's expansion and contraction. So sealant can stretch. So the sealants that you guys are using, Dow or Tremco Spec 2, even Dymonic, Dow 795, they all have some ability to stretch. Some are stretchier than others. But they can only stretch if they're adhering to two surfaces. There's something called three-way adhesion or three-sided adhesion. That's when your caulking is sticking to three surfaces instead of just two. So ultimately, when we caulk, the back of this sill flashing pieces together, when your sill is installed, the caulking will also be sticking to the back of the sill. And then what happens is, when these expand and contract, that sealant won't be able to stretch and it'll tear. So we put bond breaker tape on the back of the sill so that the sealant doesn't bond to the back of the sill. It's only bonding to the ends of the flashing. Does that make sense? Okay. And we use bond breaker tape on our curtain wall splice joints as well for the same reason. And I'll show that to you when we talk about the curtain walls. Okay. Okay. This is just showing again if you're using the receptor at the head, we have like end dams that we put on the head receptor. Those end dams aren't so much for water as they are for your perimeter caulk beads. Okay. At corner conditions, okay, I see a lot of leaks at corner conditions where you're miter cutting the sill flashing. And the reason I see a lot of leaks there is there's no way to miter this together and put a splice sleeve on it so that it can expand and contract at the corner. Okay, it's just not possible to do. So what we want you to do instead is use small pieces of flashing at the corners, okay, like 12-inch from the apex out to the cut end. Okay, anchor these down hard and caulk this joint. That way, this will never move. If you get expansion and contraction in your sill flashing, it's managed here and it's managed here, and it takes the stress off that joint. So it makes sense to everybody? I see a lot of them where they've got long pieces of flashing coming to the corner, and when it gets cold, it pulls apart, and then you get leaks. Yes, sir?
Never mind. It's just your buddy.
No, it's not.
You said hard down, like you still need shim.
Yes.
Yeah.
Yes, but again, this is a hard splice.
Yeah, I got you.
Hard, when I say hard, I mean the splice is hard. These are dynamic joints. This one's a fixed joint. Okay. Okay. At your door jam conditions. Okay. Remember, the door jam has to sit down on the ground. The door jam can't sit up on the. Why does the door jam got to sit down on the ground?
threshold?
Yeah, because you got a threshold, and we have the Americans with Disabilities Act that say your threshold can't be over a half-inch high. And if you're raising that door jamb up, you're raising the threshold up, and we're setting ourselves up for civil rights lawyers coming in and handing you a subpoena in the parking lot one day, okay? So what we want to do is we want to run the door jambs all the way down, but we want to treat the back side of a door jamb like we do an end dam, and we want to make sure we're sealing the back of the door jamb to the sill flashing in a way that after you put this frame in, you snap the pocket filler in here, any water that runs down the pocket filler will be diverted out onto the sill flashing where it can drain out the weep holes. You guys follow me? So typically what I see guys do, you have a void area under here. They'll take a couple pieces of backer rod and lay them down in here and then put a skin of silicone over them. So again, so the moisture can come out onto the sill flashing, okay?
It's a tricky area.
It's tricky. It's tricky, okay? But you know what? If it was easy, they wouldn't have to pay us, right? Okay? So now we've got our sill flashing installed. Again, this is going to be kind of like page 24. Please pay very close attention to what I'm telling you here because I see a lot of leaks occur because guys aren't doing this stuff right. Okay? After we get through this, we'll take a little break. So again, after the flashing is installed, you've got the sill flashing installed. When you are ready to start setting the frame onto the sill flashing, you need to run a bead of caulking across the top of the upturned leg of the sill flashing. You see where I'm talking about right here? And that sealant needs to be wet when you set the frame in there. So in other words, don't install the flashing on Friday and run that bead on Friday and then come out Monday and start setting frames. We need for this sealant back here to be wet when you install the frame, okay? So you set this frame down, and this is the area that I'm talking about. That little groove, remember that where the groove in the sill flashing where the little leg from the end dam goes? That's where I'm talking about, right in there, all the way across, all right? So we set this frame in, and this is the female mullion half. Before you snap the next frame in, you need to run a bead of sealant 6 inches up on the inside of that leg right there in the female half before you snap this in. Okay, the area that I'm talking about is right here. You follow me? Do you guys all see that? Okay, you need to do that, and that needs to be wet when you snap this one in. Okay, that's another one of those things. You can do 10 jobs, and probably 4 of them won't leak, but you'll get that one where it wants to suck water in where these two pieces snap together, especially if the frame's got a little bit of twist in it, and it's not snapped together as tightly at the end as it might normally be. Water will come up in here, and during a test, it'll drip down on the inside. Yes, sir?
I didn't know that. Yeah, I've never done that.
Yeah, I know.
Yeah.
A lot of people. I get that a lot. Okay, so this is again one of these things. I'm here telling you about it, and I hope it makes sense. When you have these narrow pieces that snap together, when you're sucking air from the inside, and this down here, this is full of water, it's going to want to go up into those skinny, narrow places. This is preventing it, and that's what this is for too. So a lot of phone calls like, I got leaks, it's coming in, it's coming in. Where's it coming in? And they'll say, it's coming in at the seam between the top of the sill flashing and the back of the sill mullion. And I go, okay, did you caulk the top of the upturned leg of the sill flashing? And what do? They'll lie to me. Oh, yeah, we did that. Okay, then how in the hell can water possibly come up there? It can't. So I end up going to the job site, I pull out my Bart Harrington business card, and I stick it down in there, and there's no caulking in there, okay? So again, if you got water coming up in here, which it will want to do, when you've got pressure and it's sucking, it's going to want to come up in there. That's why we need to caulk the top. Now, I see guys all the time caulking down at the bottom, or they don't do anything. If you're caulking down here at the bottom, don't even waste the money on the caulking. It's doing nothing for you. It really needs to be up here at the top, and then that little 6-inch thing up the inside. You don't need to do 6 inches on the outside. If it comes up on the outside, it's just going to go outside the building, so it's not a big deal. It's a bigger deal on the inside. Is everybody clear on that?
Yeah.
Okay, so across the top of the upturned leg of the sill flashing, and then of course this 6-inch thing right here, just right in that area right there. Okay, that's got to be done in the field. Unless you're snapping the frames together in the shop, then it needs to be done in the shop. Okay? And then once the frames are set, guess what? You remember these screws? Then you can run these little stainless steel screws down to attach the sill to the sill flashing. And those screws are not sealed. Okay? Everybody good? All right. Let's take a break. I got 15. You guys want to take 15 minutes?
Yes.
Okay. So I got 9:35. We'll start back up at 10 till. Okay. Did somebody back there have a question? No? Just stretching?
Yeah.
Okay.
You were talking about caulking 6 inches up on the male part. That was for
on the female.
On the female. Oh yeah, yes, on the female. It was for preventing stuff to come into the frame. Right, not there.
No, what will happen is, and I'll show you in a minute. During a water test, the sill flashing fills up with water.
Okay.
The pressure difference between the inside and the outside causes it to build up. How high it builds up is a function of what the actual pressure difference is.
That's with the bead holes on the outside?
Yes.
Okay.
Yeah, so what will happen is they turn on a vacuum, they apply the water, and the pressure difference causes water to not come out the weep holes. So the water will drip off the water deflectors and it'll build up in the sill flashing. Once, depending on the water pressure, once it reaches the water head height, which is a physics thing, then the water's heavy enough to where it will start to drain. It basically drains at about the same rate that it comes in. But when you've got very narrow areas, like where mullions snap together, or where the sill and the horizontal, sill flashing and the horizontal come together, you get a more rapid flow of air, kind of like rapids in a river, where you've got water and pressure flowing at the same rate. Now you've got an obstacle, so the water has to accelerate to get around it. That's what happens in those skinny areas.
Okay.
Yeah.
That makes a little more sense.
Yeah.
All right.
And I was going to kind of get into that after
a little bit
we get back, so you're good. Oh, there was a lot of talk about you in here. Good to see you. You just get dinner last night.
I know. I'm sorry. I see it's come first.
Yeah, I know.
How you been?
I've got grandkids now. They come first.
Oh my goodness, yeah.
Yeah, my kids they're now in like second or third after the grandkids.
It's funny how we just keep going down the ladder.
Yeah.
But
everybody's doing what they're supposed to be doing.
That's great. Yeah.
I've got a 6-year-old grandson. You have a 6-year-old, right?
No.
No, Matt's is 6.
Matt's is 6.
Yeah.
Yes. Ours is thankfully older than that at this point.
How old?
So our older one is about to be 20.
Oof.
I know. He's out Indiana college.
So he's doing what he's supposed to be doing. Where's he going to school?
Purdue, but he's going for business management.
Have you met John McGill? He's the director of our project, the project business group, the major projects guy.
Yeah.
He's got a degree from Purdue.
He's a pretty guy.
Yeah. He's a Georgia fan now because his daughters went to Georgia.
Oh, there you go. That's it's funny how that works too. Because now I'm like, hey,
you're a Purdue guy.
Sports because my son being there.
Yeah, that's great.
That is interesting. Yeah, we liked it out there. But so he's the one. Then we have a 13-year-old.
Oh,
so
is that a boy also?
Also a boy. So that's
he's
in that in between stage.
Messy bedroom.
Oh yeah,
doesn't want to take a shower.
Right.
Yeah.
You got it. Nailed it. Just that's the last week.
Yeah. See, I had girls, so the 13 thing was different for me, but it was
different.
a pain in the ass.
Yeah, different pains.
Yeah.
So, but yeah, he's definitely that kind. Still the same. He's a little moody.
Yeah.
He's a good guy.
Good. So you were with him last night?
Yes, he has
basketball.
Basketball.
Yeah.
You know, he plays basketball for his Catholic school.
Good deal.
You know,
yeah, that's fun.
So, but yeah,
that's fun. Yeah, I know when my daughters were playing soccer, I couldn't miss a game. I couldn't miss a game.
Yeah.
And my wife, she would go, like, if I had to miss a game because I was traveling, or if I was playing tennis at the time, if I couldn't be there, I was like, I didn't understand why she couldn't call and give me updates. You know, I'd call her, say, and she wouldn't even answer the phone. I go, hey, what's going on? What's happening? I go, well, halftime? What the hell? What did I miss? Oh, Kelly scored 2 goals and they're winning 5-0. And I'm like, well, God, all you got to do is send me a text or call me or something. Yeah, okay. And then nothing until the end of the game.
It's funny you say that because I was texting Jody last night. End of the first quarter, we're up this. But it's funny. I was a steady stream of guys heading down as I was coming up. And I said, you guys getting all educated? One of them was like, no, we're not doing.
Well, we talked about some. There's some things they're not doing. So, Joe is down in Mexico.
Yes.
What's he doing? Just fishing, or?
They went to a resort with the family.
Exactly.
His whole family.
Okay. Wait a minute. It's been a while. He got divorced. Did he marry?
No, he has a permit.
Oh, okay. Okay, good.
Good.
Took the kids down.
Yes, she's great with. She's a little younger than he is, and I only say that because means her mother is not terribly old. You know, like her. So her mother kind of is great with my niece and nephew.
Oh, good.
It kind of works out. It's a nice.
That makes family thing. That can either be
for everybody.
So, him and his wife kind of separated.
That's
good. They're the older.
It's really
my
bad.
nephew is still only like 15.
So
about 3 years before they're out the house.
Well, tell him I said hi.
I sure will. I'm hoping he's fishing, but definitely.
Well, Jody says I may be coming back again in April or May or something.
I think it would be valuable to teach some of the newer office employees, you know, this lesson, but maybe not as technical. But, well, it seems like guys.
Yeah, they're reacting well to it. I think it's clear that there's some things that are not being done.
Oh, sure.
You know, Bart, too, with that, after maybe you digest over the next couple days, I would love if you could educate us that this is the feedback we got, that this is what you're not doing.
I will, because there were definitely some things, especially some things here in the shop.
The fabrication.
The assembly that are not getting done that need to be done.
Okay.
And there was some deer in the headlights and some acknowledgement that some of those things aren't getting done.
Okay.
And so
that would be great, because the goal is for us to be better.
Yes. Yep. And I suggested that they talk to you guys about it.
Right.
But I can certainly share that information as well.
That would be great. That would be great.
Yeah. So it's the same stuff. I've been doing this for so long.
I thought I said that.
These guys. Some of the guys are going, these things, the ceiling, the horizontal like this, is this new? I go, well, I don't know. I've been doing this for 40 years, and it's been pretty much the same the whole time. Yeah, that hadn't really changed. Yeah. But I think that, a lot of these guys, I think there's a lot of tribal knowledge that goes on. And sometimes it's like the telephone game,
That's it. It's handed down from one installer who's been doing it forever, and it's not always right.
And it's not always accurately relayed, and so what ends up happening is people end up having to learn by their mistakes rather than preventing, from happening in the first place. So we've been talking about that kind of stuff. So.
That's good, and that's exactly why you're here.
Yep.
Because you need to be refreshed and make us aware of things. And with each time, I like to think we get a little better.
Yeah, well, and that's it. I asked the guys when we started, I said, how many of you guys have been through one of these things with me before? And there were, I don't know, maybe a dozen guys. Had some. And it doesn't hurt to hear that stuff over and over again. No. I was up doing the same thing with a customer in Detroit 2 weeks ago, and this was over the years, this was the 4th time I had been up there.
Okay.
And the owner of the company actually sat in on the training with the guys. And he goes, okay, I know we're doing this. Guys, back me up. We're doing this, right? He goes, but I don't think we're doing this and this.
Yeah.
And they go, no, we're not doing that. So he goes, maybe by the next time you come up, we can sit here and go, yep, we're doing all that stuff.
Exactly. Yeah. Yeah, absolutely.
Yeah.
And I know the training is a big part of what you do.
Yeah.
But are you still doing site visits?
Yeah. It's funny. Oliver always asks. I don't see Oliver that much anymore. Mike's the president, and I report to Mike.
Yeah.
So I just kind of bump into Oliver every now and then. He goes, are you still getting as many calls about field stuff? And I said, I don't think so.
Mm-hmm.
I really don't. And I think there's two reasons for that. First of all, I would like to say I think it's because we've done so much training that at some point there has been a cumulative buildup of that. On the other hand, I can be such an asshole. But I think a lot of times they don't want to call me.
That's the deterrent.
And like Michelle is the queen. So Michelle Pearson, she only calls me in on something if she knows something's wrong and she wants me to be the bad guy instead of her.
Yeah.
And I'm okay with that.
Exactly.
I'm okay with that. But unfortunately, I have to deal with a lot of, the company. First of all, they want me. We spend a lot of money on installation instructions and training and stuff.
Yeah.
And they feel like I need to be making sure that I'm vetting these things properly before I go.
Right.
And so the biggest problem I have is less than truthful feedback to my questions.
Yes.
It makes sense.
And so what they want is either the guy that I'm talking to hasn't actually been to the job site. So he's got some guy in the field and he goes, hey, did you caulk those end dams and those water deflectors? And the guy in the field, what's he going to say? Is he going to say
he's
no?
not going to tell you no.
Yeah, we did all that. No, they did it. And I'm like, okay, let me get a plane ticket and a rental car and come up there. And what do I find? It's always the same stuff. It always is. And they want it to be something different. A lot of times I get we think the gaskets are out of tolerance, or we think the extrusions are out of tolerance. Which it could be. You guys get material. But usually you find that out pretty early on.
Right.
When you're putting stuff together and glazing it, is when you know it's not later on when it's leaking that you notice there's a problem.
Yeah.
So that's been my experience with it. So I feel like I'm spending less time doing that and more time doing the training, which it doesn't matter to me. And then, every once in a while I've got to go somewhere because there's going to be a lawsuit or something, and they want me to gauge what our exposure is. Is this really defective product, or is this another one of those things? And it's almost always another one of those things.
That's what I was going to say.
I'm like, what I envision is myself sitting in a courtroom wearing a suit, and some guy's asking me a bunch of questions, and I'm just kicking his ass. It's like in the movies, right? You want to be the guy that wins because I feel like they shouldn't be suing us.
Right.
And I actually got out of jury duty a couple of years ago. I was being interviewed for jury duty, and the guy says, "Is there any reason you think you can't be impartial in this?" And I said, "Yes." And he goes, "What?" I said, "Yeah." I said, "I don't mind doing like a criminal trial."
Right.
Where, but civil trials, I said, I think we badly need tort reform. And the judge goes, batshit. He slams his gavel down. He goes, "Get your ass up here." And I go up there and he's going, "Look," he goes, "I got to handle a jury. I can't have these people going to their cell phones at lunchtime looking up tort reform." So I have very definite feelings about that. Like when people are trying to sue us for something that very clearly isn't our problem.
Right.
But unfortunately, insurance companies
the way
and
of the world
the
right
cost
now.
Of litigation being what it is.
Hey, it's cheaper to settle.
Yeah, it is.
Yep.
There was a job we did up in what is it where Springsteen's from?
Asbury Park. Yeah.
And they had some windows that were leaking, sliding windows that were leaking, and it had evolved into a lawsuit. And by the time I got there were 5 or 6 trades out there. They were taking driving off the building. They had a lot of problems on that.
Yeah.
Project. But I looked at our windows, and the problem with the windows is when you put the horizontal sliding window in, there's a filler piece that snaps in at the end to cover it at the bottom. They didn't put that in. They just didn't do it.
Sorry.
Yeah, I don't know what happened. The glazing contractor said he got kicked off the job before he could put that part on. And I said, well, that's why I think these windows are leaking.
Right.
So you don't have that essential part that prevents water from getting up in there.
Yeah.
And so I was with, that had become a lawsuit. And I was with our local attorneys then, and I kind of showed them. And usually when we hire local attorneys, they tend to be, they're not experts in glazing, but they're experts in construction at least.
Sure.
So I can explain to them what's going on. They're going, oh, okay. So we got no skin in this game. I said, that's exactly right.
Yeah.
So later on, I find out we settled they were suing us for like $3 million or something, and we settled for like $20,000.
Wow.
And I'm like, you got to be kidding me.
Because even that frosts you, right?
Yeah,
You're like,
the
no.
guy from Tokyo Marine, our insurance carrier, called me up and says, hey, great job on that thing up in Asbury Park. He goes, we settled that for $20,000, and I'm like, you got to be kidding me!
Yeah,
Why did you give him a penny? He goes, because if we had gone on one more day, it would have cost us twice that amount.
Exactly. Yeah.
So,
which is unfortunate.
Yeah, it is. That's what I mean about the tort reform.
Yep. Exactly.
Well, be careful, because the judge said, he goes, you're dismissed. I want you to walk out of this courtroom and not talk to anybody else. And so there was a guy I'd been sitting next to that worked for the Braves. And so as I'm walking by, he kind of goes like this. He winks at me and gives me the thumbs up. Yeah. So I probably came pretty close to getting contempt of court.
How about that? Just being.
Yeah, I was just being. Yeah, I thought, well, what the hell? I don't want to do this.
Yeah.
I got to get back to work. And
yeah.
I've been on jury. I've been on a jury before for a criminal case. So it's not like I need the experience.
Yeah.
Right, exactly.
Wow.
Tort reform. That's
tort reform.
It's got to be on a civil case, not a criminal case.
Yeah.
In this particular case, what was happening was a family of people had gotten in a car accident with a guy, and it was the guy's fault.
Okay.
And they had already sued him and won, but they wanted additional money because they had an infant, and they wanted to sue him for a trust fund in case there were unforeseen problems down there.
Yeah.
Exactly.
Yeah.
And so I'm sitting there going,
like you already got what you got, and now
I don't know. I don't know about this.
Yeah.
So. Yeah.
What can I get you, Barb?
I'm good.
You
Everything's
sure?
fine. Yep.
Okay.
Yep. They're doing great.
Wonderful.
Staying alert, asking questions. We're talking
Fantastic.
about.
Oh, sorry. Fantastic.
Good to see you.
All right. Very good. Very good.
Are you George Ray?
Yeah.
I'm sorry, my phone. No, they don't got a charger. Over there, there's a strip. They're all in the corner over there. I knew I shouldn't pull my damn batteries out. Huh?
There's a strip right there. An electrical strip.
No, I'll wait. I got time. So far, so good.
That's what you need. Get the set moving along, you know. Shit, I'm not
Oh,
One.
The last stuff we had,
2 hours and halfway through school.
Yep.
I thought that was going to be 20 minutes.
Is that what I'll come eat lunch for you for free. B, front of the class. You after your late? See?
We were talking about you.
Yeah, how handsome I am, I bet. Way better looking than Jim.
Was it handsome or
Actually more similar than Jim.
Yeah, I'm aware. You know, he's the one you like. I can't know all the superlatives. Thank you. You just shot right.
Yeah, shot, please. Okay. You guys ready to roll on a little bit? Sure. We're still missing a couple, but we got to keep moving, okay? If you want to get out of here by 6 o'clock, okay, let's move ahead, okay? Hey guys, see you, Mike. Hey Ivan, come here a second. Come here. All the way here. I got one for you.
Okay.
All right. This came by the way, gentlemen. This is Ivan Zuniga. He is the YKK AE Director of Product Development. So who was it that asked the question about the adjustment block in the top rail?
He's outside.
He's outside. So you know the glass block in the top rail of the door we have for adjusting the door up and down?
Yeah.
So there he is right there. So here, this is the guy. This is the guy.
Yeah.
Oh, I thought it was you. Somebody else. Okay, so we have the nylon block. The nylon block up there is rectangular.
Okay.
And so if you have monolithic glass, it's supposed to be parallel to the plane of the glass. If you have insulating glass, you're supposed to turn it so that when you press down, you're not pressing the spacer in. You're pressing down on top of both plates of glass to raise that door up. Okay. It's a white nylon block. The question or the comment came in, which I have never heard before, that even when you turn that the right way, when you tighten it, if the door is really heavy, it's still, what it does is it flexes and still pushes the spacer down.
Oh.
Okay.
So we need something.
I actually have a picture from yesterday of this scenario.
Okay.
So I'll share that when I come back.
Yeah. And that's a perfect example of something that I wanted to share with you all. You know, you will think that, all the smart engineers, they can come up with a great idea. But the truth of the matter is that if we understanding your pain points, the things that you see that, hey, why is this not working correctly? That feedback is invaluable because most of the enhancements and new developments come from voice of the customer, right? And you are our customer. You install this on a daily basis in different applications, so you've seen it all. And by all means, any idea or any pain point that you see, please bring it up to Matt and Jody so that they can tell the sales rep Jim and come up to us, because if we know those pain points, then we can start looking into them, coming up to see how we're going to resolve it. The other thing that I'm very keen on is making sure that we don't develop something and don't show it to you first. Hey, you came up with the idea, or I want to show it to you and see whether you think that that's going to be a good solution. So by all means, the other thing is you're going to see a lot of documentation that Bart is using in the presentation, all the installation instructions. I always tell my team, it's like, it makes sense because you wrote it. But if somebody is coming cold and reads it and doesn't understand it, then that document doesn't have any value. So by all means, if there are any areas or something, just raise your hand, let us know, because the more comprehensive and understandable we make that document, the better your lives are, right? It's like, do you read this on a daily basis on every job? No, but you want it to be understandable when you need it, right? So by all means, anything that is either the technical literature or ideas in the pain points, let us know, because it's through your voice that we can make the products better.
And then, yes.
Some of your competitors, when I started in the industry, their block was actually an aluminum block that had a piece of rubber laminated on it. So it couldn't.
Conyers was around nylon.
Yeah, around nylon.
Now, there was another comment made about the new thermal doors. Who's talking? Okay, yeah, the guy in the Philly set back there. What was your? He was saying that the block. Go ahead and explain it.
That same clip that they're talking about with the thermal, it's so tight to the thermal break that when you put the set screw in to set the glass in the door, it's so much pressure on it that me personally, I think it was going to pop the unit because of how much pressure that's on the screw.
I'll track this.
We'll look into that, but I really appreciate your feedback, and by all means, the more the merrier.
They just talked about your block, bro.
From now on, it's going to be referred as Jim Block, right? You need to adjust Jim's block. And it's like, ooh, what?
Okay, thank you.
Hey, thank you all. Thanks.
Have a safe trip home. When are you guys leaving?
This afternoon.
Oh, you're not till after lunch?
Yeah.
Okay, so we left off, we were talking about setting the frames in the opening and making sure that we're sealing the top of the upturned leg and 6 inches up the vertical. And this next screen here is what I'm trying to explain here is what's actually occurring inside the system during a wind and rain event or during a field water test, where you have high pressure on the outside, low pressure on the inside. So the pressure difference, high pressure outside, low pressure inside, causes this water inside the sill flashing to want to build up to a waterhead height. This is all determined by physics. This is not something that we designed the system to do. It's just what physics causes to happen during a wind and rain event. So, like, for example, when you guys, how many of you, again, have witnessed a water test? So when they're doing a water test, they're testing it to a certain pressure. And if you look at their gauging equipment, the pressure that we typically look at is in terms of PSF, like 8 pounds per square foot, 10 pounds per square foot, or 12 pounds per square foot. But when the engineers in the field are testing it, what they're looking at is inches of water. So at an 8-pound pressure difference, there's a constant number, and again, it's physics. It's 0.192 times the number of pounds. So if you take 0.192 and multiply it by 8 pounds, at an 8-pound pressure difference between the inside and the outside, you get 1.54 inches of water that builds up in the sill flashing before that water becomes heavy enough to offset that 8-pound difference, and then it starts to drain. So if you ever watch what happens during a water test, you'll see at the very beginning, hardly any water will be coming out. And then a couple minutes into the test, some water will start coming out. And then after they turn the test off, it'll continue to drain. All the water drains out when they turn off the vacuum on the inside. Okay? During a 10-pound water test, we get 1.92 inches of water. That comes up to here. Okay? During a 12-pound water test, we get 2.3 inches of water. Guess what? That water comes up this high. Okay? That's how much water is sitting inside your sill flashing during a test. So that's 6 inches sealing up there. That's so that air pressure doesn't suck water up that little seam where you're snapping the pocket filler into the female mullion. And sealing the top of the upturned leg of the sill flashing is so that water doesn't get squeezed by pressure up here. Okay? That's why that stuff is so critical. This is not anything other than the physics of what goes on. And it doesn't matter whose system it is, the physics is always going to be the same. We're all dealing with the same thing. So it's a question of, how consistently we manufacture our material and how closely you guys follow the installation instructions that becomes the key to performance. Okay? Does that make sense to everybody? That's just physics. That's just the science behind what goes on. Okay. If you're installing with the receptor up at the head, this is just kind of showing how you rotate the receptor into place, and then this thing snaps in. The expansion mullions. This is if you have expansion mullions in your storefront, remember they have to be used every 12 to 15 feet where you have long runs of storefront framing. And again, when you install the expansion mullions, you'll notice we have a 2-inch minimum width, and then we have a 2 1/8 or a 2-inch nominal width and a 2 1/8 inch maximum width. So when you're installing the expansion mullions, if it's in hot weather that you're installing it, okay, if you're installing it when it's hot, you're going to want to squeeze these mullions together. Okay, that way when it gets cold and the horizontal shrink, this can expand a little bit. Okay, that takes the stress off your perimeter caulk beads. It prevents your snap together mullions from unsnapping, and it takes the pressure off your door jambs. If you're installing in cold weather, you're going to want to spread the mullion apart a little bit so that when it gets hot and the horizontals expand, this can squeeze together. Okay? Does that make sense to everybody? Okay. And of course, ultimately, this is what your properly installed sill flashing looks like. Shimmed up, fasteners sealed. Remember, no sealant on this screw. But we need to seal any penetrations in the sill flashing have to be sealed. And of course, sealed up here at the top. Okay? We talked about this, didn't we? What do you think?
Fail.
Yeah, that's obviously that's not a good. First of all, architects don't like it. They don't, they'll quibble about any exposed fastener, right? But certainly this one. Think about the end. Remember what I said about the end reaction? Do you think that screw is actually going to stop that mullion from moving? No. But all it's done is rust, and obviously it's leaking too.
Isn't that your old sill pan, not your hot?
That is our old sill pan. Yes. Yeah, but still, even with our old sill pan, we didn't recommend doing that. Okay. Look at this guy. Now this guy, he used 2 screws there, but look what happened. What's happening to the sheetrock here? Right? Yeah. Right?
That's the old.
That's the old one. How you like that?
Nice.
Right? Looks good. If you forget, hey guys, listen, I've got a slideshow. I've got a slideshow of nothing but this kind of stuff. If we get time, I'll run through that at the end of the day. Okay. What happened here? Can anybody tell me what happened here? Or the expansion, but they didn't shim it up, did they?
Oh, surface to surface.
Yeah, they did surface to surface, bedded this in sealant, right? And then when the aluminum expanded and contracted, it tore. Now look, this is the balcony on the outside. You see what this is on the inside? That's the glue where the hardwood flooring used to be. Guess where the hardwood flooring is? In the trash. So they had on this condo, the only reason is because he didn't shim his sill flashing up, they had 10 units in this condo to the tune of $10,000 per unit. They had to put in new hardwood floors. Okay? Okay. Here's another one that's important for you to know, and I mentioned this earlier on too. When we go to do the perimeter caulk beads, okay, I think we all kind of intuitively know that we need to have the perimeter caulk beads on the outside, correct? We have to have them on the inside too. Okay. Now the idea is not that we're going to prevent water from coming into the building because we have a perimeter caulk bead on the inside. The idea is that we're stopping airflow around the frame, okay? Now, if you remember that water coming up to the very top of the sill flashing during the 12-pound water test, imagine if you have air inside the frame rushing towards the end dam. What's going to happen to that water? It's going to push it right over the end tabs, okay? Now, the reason that I'm taking the time to point this out is because, again, if you're doing a field water test, the testing engineers will not want you to put the interior caulk bead in, okay? The reason they don't want, why do you think they want you to not put in the interior caulk bead? Yeah, so they want to be able to see if there's water under here during the test and after the test, okay? But if you don't have that perimeter caulk bead, guess what you're going to have? You're going to have water, okay? Or at the very least, if they do an air infiltration test, you won't pass that, okay? So first of all, the testing standards require that the installation has to be complete. And we don't consider the installation complete until you have that interior perimeter caulk bead, okay? So it's required for the system. Now, curtain wall systems are different. Curtain wall systems manage air and water differently than storefront systems do, but storefront systems and window wall systems, for that matter, all require the interior caulk bead, okay? And then, of course, wherever you have fasteners that are penetrating the frame into the surrounding condition, make sure that you seal those fastener heads. So typically with a system like this, we're going to drill holes in the glass pocket area, okay? A couple of things about that. These holes have to be countersunk. We have to use flathead fasteners there, right? What happens if you use a round head or a hex head fastener here?
Break my blade.
And when you go to set your glass, you're going to bump it into the fastener head and crack your glass or break it, okay? The other thing I want you to notice is we are not drilling through or anchoring through the thermal break material, right? Please don't do that. And it's not necessarily that it's because drilling holes in the thermal break material is going to damage anything. It's really more because when the anchors are under shear or under moment caused by the wind or building movement, we want it bearing on the aluminum. We don't want it bearing on that polyurethane. Okay? If you get a lot of flexing in and out on a fastener going through that polyurethane, it will damage the polyurethane and you'll have all kinds of problems. Okay? So just remember, that's one of the reasons that we have the thermal break offset in the glass pocket the way we do. And just so you know, when the thermal break is offset in the glass pocket, it should always be towards the outside. Okay? That's just for thermal performance. Okay? Also notice that wherever we have a fastener going into the surrounding condition, in this case at the jamb, but certainly at the head, we have to have what? We have to have an aluminum filler there.
Oh, yeah.
Okay? Now, I don't know what do you guys do? How do you guys typically install the frames? Do you put full length fillers in or just the short pieces, or what is your practice as a company?
Full length.
You use a full length? Aluminum fillers? Plastic ones? Okay. At the anchor locations, you have to have aluminum fillers. Those plastic fillers, the plastic fillers aren't cutting it. Okay. The reason that we have to anchor through the filler is to get the perimeter anchor in proper shear. Okay. So we have to have the anchor bearing on the mullion and on the filler, and then before it goes into the substrate. Okay. The problem with the the plastic filler is it's too flimsy for bearing the moment, and they'll unsnap or they just won't function properly. They'll allow for too much movement. So the really proper thing for you to do is to use the plastic fillers, intermittently, and then just use the aluminum fillers where you have an anchor. Okay?
I always have problems with guys when they're installing stuff like that. The frames always get happy or sad because you're shimming it.
Yeah.
And the plastic just.
Yeah.
You're not going from leg to leg of the 4.5 inch
Yeah.
frame.
That's the other reason is the aluminum fillers bear better with the shims and everything. You're talking about smiling frames.
Yes.
Okay. Any questions about that? If you want to use the aluminum fillers to run the full length, you can do that too. I would recommend, though, instead of using this filler, we have another filler that has a thermal break in it. Okay? Because if you run this a flat aluminum filler the entire length of the extrusion, you're bridging the thermal break and you're going to have condensation problems. Okay? So if you're going to use this, if you're going to use the plastic one with this flat filler, that's fine. If you decide to switch to the aluminum filler, it needs to be the one that has the thermal break in it.
You guys still using just a punch out thermal for its pocket?
That's on the vertical pockets,
right?
Not on these.
So you guys aren't going full thermal on that now?
We have a on our XT storefront system, which this is our standard TU storefront. We have an XT one. The XT storefront has a dual pour into bridge, and then we have a composite snap-in filler that has a thermal break. Okay, but we get very good thermal performance with the slotted. We call it thermal slot. Okay, and this is what I was talking about here, making sure that we're countersinking these anchor holes and then sealing the heads of the fasteners. Okay, there's your the two-piece receptor again. Water deflectors. Okay, you guys are installing water deflectors, right? Yes, please. You guys are installing water deflectors? No? Seriously?
Seriously.
Okay, that's all right. Let's talk about it, okay? Yeah.
It says seal the head. So I put a storefront frame in, we should be caulking those screws also?
Yes. Yeah. Let me back up. Everybody, time out. We'll talk about the water deflectors again in just a second. So, yes, whenever you have fasteners penetrating the glass pocket, you want to seal those screw heads. Okay? That's for air. That's to prevent air whistling and stuff like that. Okay? So the water deflectors. The water deflector is a plastic part. It's flat and it's got a ramp on it. And it's got sticky tape on the underside. Okay? That's what this is showing right here. It's black plastic. Okay? And the way that it's installed is you clean off the end of the horizontal mullion, you peel the sticky tape off of the water deflector, you press it down, and then what you end up with is the water deflector sitting on top of the intermediate horizontal, and then you're going to seal it to the top of the horizontal. What that's for is to direct the water down the vertical glass pocket. Okay? That's only done at the intermediate horizontals. You don't need to do this at the sill. You don't need to do it at the head. Okay? The reason that you have to have it is because these systems are what we call flush glaze systems. That means you have pockets in the mullions and the glass is fitting into the pockets. So when you have a system like this one right here, we have a glass size formula, and the glass size formula is daylight opening plus 3/4 of an inch. You guys ever heard that before? Okay. So that means we've got 3/8 of an inch glass bite on both sides of a lighted glass and 3/8 of an inch glass bite above and below it. So what you end up with is a light of glass that's actually just a little bit longer or wider than the horizontal is long. Okay, so what we're showing in this diagram here, this is our vertical mullion right here, right? And this is the horizontal mullion, and the horizontal mullion comes right up to the vertical mullion. When the glass is installed, the glass actually sticks into that vertical pocket a little bit, right? So what happens during a wind and rain event is water gets into the horizontal glass pocket, and it builds up until it drips off the end of the horizontal, and what's it drip on top of?
Silicone.
The glass that's sealed with silicone, right? And that water builds up on top of there until it spills off on the inside, and you get water running from the underside of that horizontal gasket and running down across the face of the glass, or the water just sits on top of the glass until the IGU seal fails and it fogs up. You follow me? Everybody with me?
Yep.
Okay, so the reason we put the water deflectors in is to divert the water past the edge of the glass so that it can run down that vertical pocket to the sill flashing and evacuate through the weep holes.
So is the backer rod and caulk in the horizontals?
The backer rod and caulk in the horizontal is right under here.
Is that like a backup protection?
Well, yes and no. I mean, if you have air getting sucked through, and this, instead of dripping off, it'll get sucked back up under there. You follow me? Okay. But these water deflectors are critical. Okay. It's like anything else. Everything I've shown you up till now. If you don't do any of it right, any one of those things can leak. The things that I showed you on page 24, the things that I showed you about sealing, the top of the upturned leg of the sill flashing, all of that stuff is important. The water deflector is the next thing. And I see a lot of leaks because either the water deflector wasn't installed or it wasn't sealed properly. You remember when we were assembling the frames and I showed putting sealant in that reglet? You remember that? So when you put the water deflector on, you basically want to marry the sealant around the water deflector to the sealant that's in that reglet. That way, again, a lot of times what I'll do if I'm looking at this stuff in the field, as I carry those little flashlights before the glass is in here, just look down from above and hold a flashlight underneath that. And if you can see daylight anywhere in here, it's going to leak. Okay? That's what the sealant is for, so that the only path the water has to take is off the end of the water deflector. Okay? So that's another thing that you got to make sure you're doing. That's, again, not at the head or not at the sill. That's only at the intermediate horizontals. Okay?
And do we have to order them from you, or are they parts that come with the material?
There's nothing that comes. The only thing that you get are the parts that you order. So it has its separate part number. They come in bags. There's 50 of them in a bag or whatever the hell it is. And they're cheap. I don't even know what. By the way, in my role, I don't know or care how much stuff costs. So I can't tell you. They're cheap though. It's a cheap little piece of plastic with sticky tape on it. But the sticky tape is not forever sticky tape. That's what the sealant is for. And the idea with the sealant is you got V grooves right here. You got the thermal break. You don't want the water going under the water deflector. So we're putting sealant on it. And the corollary to this is the guys that put too much sealant on it. And they call me, we failed a water test. What happened? Well, the water was coming up on top of the horizontal. It was coming up through the gasket on top of the horizontals. Well, hell, you got this big hole at the end. You'd have to completely fill that hole up for the water to be able to build up. So, like I said, it's pretty easy to figure out, what's going on based on, what kind of leaks they're getting. Okay? But yeah, my bet would be if we went down, I got to believe you guys have got bags of these things here.
I bet you. I don't think I've ever seen that.
Absolutely.
We do. No, we did it back with Bill.
Now, I don't want to start a mutiny here.
I'm going by what I was taught. You know what I mean?
But I'd be willing. Okay, so basically, the water deflectors. By the way, the water deflectors are another item that can be applied in the shop. Okay, the water deflectors can absolutely be applied in the shop, and they probably should be. Okay. I'm really creating a problem here today. You guys all with me, right?
Yeah.
You understand why this stuff's important, okay? All right. Okay. The glazing gaskets. You guys love those greasy glazing gaskets, right? What's that grease? What's that grease that's on the glazing gaskets? You guys know what that is?
Fish juice.
Fish juice. Anybody? It's liquid silicone is what it is. They spray it on the gaskets. It's part of the, it's actually done when the gaskets are manufactured. So we don't actually manufacture the gaskets in Dublin. That's a vendor item. And we have, Tremco and some other companies that we buy the gaskets from. But that that liquid that's on the gaskets is a lubricant that's there to make the gaskets easier to install. So that's there for you. It's to make it easier. And so I'll tell you a couple of things about that. Every once in a while, and I don't know why this happens or how it happens, our vendor sends us gaskets with a lot of that oil on them, okay? And you can tell. You'll see the box of gaskets, and it'll look like it's got a pizza in it where the grease is soaking through it, right? And I don't know why that sometimes happens and why sometimes it doesn't, but it does. I keep track of what our competitors are doing, and I like to go on their news feeds and I see announcements and stuff. And I'm not going to name the company, but one of our, and because the reason I bring this up is because some of our sales reps and some of our customers complain about the grease on the gaskets because they have to wipe it off and it's a mess and it doesn't taste very good on your fingers. And if you wipe your forehead, it drips down in your eyes and it stings your eyes and all that stuff. It's not, I get that. I had to do all that too. But it's not toxic. That's number one. And some people are more sensitive than others. Some guys, they'll take their hand and go like this, and they'll have a big red handprint on their forehead. Other guys don't seem to mind it as much. But about 4 or 5 years ago, I was looking at one of our competitors' websites, and they had a news announcement. And their news announcement was that they were offering their gaskets with or without the lubricant. So if we had customers that didn't like the lubricant, they could order them dry. Okay, so I thought, well, that's kind of interesting, and I knew exactly what was going on when I read that. I talked to people, I know these things. So, oh, that's interesting. And so then maybe 8 months later, I go to their website and there's a letter rescinding that offer. Yeah, we are no longer going to be offering the dry gaskets, and I know why. I know why it wasn't going to work because if you guys had to install these gaskets, and right now, one of the things that we run into in our industry is glass tolerance issues, right? Sometimes the glass is a little bit thin, and sometimes the glass is a little bit thick. The thicker the glass is, the harder it is to press those gaskets in. And so you run into, and again, there's reasons for that too, by the way. I don't know if you guys knew this or not, but when we design our framing systems, we design everything using imperial measurements. Right? When the glass manufacturers are manufacturing glass, they're using the metric system, right? So what's an inch to us is X number of millimeters to somebody else. And so sometimes it gets a little bit lost in the translation. And so that's why we offer optional gaskets with our systems. So if you guys are out installing a system with our standard gaskets for 1 inch glass and the gaskets feel loose, we actually have slightly thicker gaskets that you can use. Maybe just on one side, go with a thicker gasket to make sure you've got good compression. But the lubricant is a thing too, because again, without the lubricant, it used to be a bigger deal when they had monolithic glass that had coatings on it. And you would push the gaskets in, and if the gaskets weren't lubricated, or if they were too tight, you'd scratch that coating. And you wouldn't tell until later. You're standing 20 feet away, there's a little white line on the glass where you've scratched the coating off. So again, that's the world of gaskets. But the proper way to install the gaskets, the most important thing is to cut the gaskets to the right length. Okay, a bad technique would be to stuff the gasket in and use a roller to roll it in and then cut it. And why is that a bad technique?
Stretch the gasket the wrong way.
Yeah, when you roll, these are all these rubber gaskets that we use are what we call thermoset materials. So if you stretch them, they're not going to stay stretched. What are they going to do? They're going to shrink back to their thermoset dimension. Okay, so the ideal thing to do is to cut the gasket to the proper length, and the proper length is typically daylight opening plus. So for example, we have a thing here. If it's a vertical gasket, you're going to cut it to daylight opening plus 1/4 inch per foot of daylight opening. Same thing on the horizontal. And that 1/4 inch, what that's for is you stuff the gasket into the corners, and you stuff it in the middle, and then kind of smooth it towards the corners. It keeps the gaskets pressed tightly together at the corners and keeps them from coming apart. Okay? Then also what you're going to want to do is put sealant on the end of the horizontal gasket and press it into the vertical gasket and tool off the excess sealant. What? What?
No, what we don't do.
That's why you're here. That's why you're here.
I'm laughing with you. I'm not laughing at you. I do this for a living. I have these same conversations all day, every day. So don't feel bad, okay?
You said call just at the end.
Just on these storefront gaskets. We want the vertical gasket to run through, and we want you to caulk the end of the horizontal gasket to the vertical gasket. Now, these gaskets are silicone compatible. So the sealant, it's not going to hold the gasket together. You still got to cut the gasket to the right size. All you're doing is sealing it so that air can't get sucked up between them.
But you got to clean it first.
Well, it doesn't do you much good to clean a gasket. Unless the gasket's been laying around the job site and it's covered with construction debris, then yeah, you're probably going to want to wipe it off. Okay? The other thing I was going to tell you too is this comes up every once in a while. Like I said, sometimes the gaskets come with a lot of grease on them. Okay? And I see it even in our plant when we're putting when we ship the doors out and we have the glass stops with the gaskets in them, and I'll see like a grease stain on the door where it's kind of run off. If you have a condition where, especially, I see it more often for some reason on the door gaskets than I do even on the storefront gaskets. What will happen is I'll get a phone call from a customer saying, "Hey, what do you use to clean the grease off of the gaskets when it gets on the metal, it gets on the glass?" And the answer is isopropyl alcohol. It's not going to damage the finish. It's not going to damage the gaskets. And so they go, "Well, we tried that and it came back." It's not coming back. What's happening is that gasket has got so much grease on it that it's just continuing to leach that grease. So if you have something like that happen, where you go out there and you clean it off, and you come back the next day and the general contractor goes, "I told you to clean that." "Well, I did." You may actually need to pull the gasket out and take a rag and wipe off that excess sealant if it's that bad. Okay? So at any rate, that's how I see gaskets all the time that are cut the wrong length, and the customers tell me, "Oh, the gaskets are shrinking, and I go, "Well, how long have these gaskets been installed?" "Well, I installed them on Tuesday, and Wednesday we came out here and they've shrunk that much." I said, "Okay, let's do this. How about if I cut the gaskets and I install them, and we'll come back tomorrow? Because if there's bad gaskets, then mine will shrink too, right?" Okay. And then I cut them, and guess what? What's happened is they haven't cut them the right length. They've either rolled them in and trimmed them, or they just kind of eyeballed them and cut them. So again, that's why we want those. We want those to stay tight in the corners. So it's DLO plus 1/4 of an inch per foot. Okay, and then of course sealing the ends of the gaskets to the vertical gaskets. Okay. Any questions about the gaskets? Okay. And the gaskets are made out of EPDM, which is not like the cheap old vinyl gaskets. These gaskets will last a long time. These are high quality rubber. Okay. Yes.
Like dealing with a glass that is acid etched or frosted.
Yeah.
Nightmare.
Yes. Yep.
That frosted acid etched just keeps wicking.
I know.
You'll get a little strip like 2 inches.
I don't have a good answer for you. That's
the only thing that works is the sponge from the bald guy.
The sponge from the bald guy. Is that some New Jersey guy that I don't know? It's a sponge from the bald guy. Is he the guy that does the commercials on TV?
Yes.
What's his name? Mr. Clean. Oh, yeah. Hey, that's a good tip. So the magic eraser?
Excellent.
Really?
Yes. It's the only thing that works.
Because that's a little bit abrasive.
Nah, it doesn't hurt glass.
Okay.
If you use them salt enough, they're not that abrasive.
Do you wet it first, or do you just dry
it? Yeah, a little bit of water.
Okay. Okay. Yeah, that magic eraser is some piece of work, huh? It's the bald guy with the sponge. How am I supposed to know who that is? But now I know. Now, the bald guy with the sponge. I got you. And the earring. He wears an earring. Okay. Anything else on the gaskets? Okay. So then we're ready to set the glass. Here's another one for you. You guys are going to love this. Okay. How many setting blocks per light?
2.
What if you have a really, really big light?
3.
Never more than 2. Okay. Never more than 2. And the setting blocks should be located at quarter points of the daylight opening. Okay. Now, if you have a really big light of glass and you put the setting blocks at quarter points, like we say, and the horizontal is deflecting to the point to where it's sitting on top of the glass below it, or you can't get the glass below it under, set in there, you can move the setting blocks closer to the corners. Okay, but again, this is not a YKK thing. The reason that we call the setting blocks out for quarter points is because that's what the glass guys want. Okay, what happens is if you move the setting blocks too close to the corners of the glass, that means you're increasing the stress on the glass at that location. And the closer you get to the corners, the more likely you are to get spontaneous cracks in the glass. Okay, so and I'm not saying that you need to do this, but if you ever read the literature about, like how we have installation instructions, the glass guys have glass handling instructions too. And what they'll say is they want a setting block of a certain length and of a certain durometer. Do you guys know what durometer is?
Like the density.
The density or the hardness of it, right? So again, I've been to job sites where they've got glass lights fogging up or cracked glass lights where the guys have run out of setting blocks and they've used horseshoe shims as setting blocks. Okay? Or one was a wadded up Marlboro box. Or stacked up pieces of cardboard from their door box. They're using that stuff for holding the glass up, okay? Which, hey, I understand the need to get her done. Okay, I get that. But I'm just here to talk to you guys about responsibility and the risks you're taking by doing it. Because what'll usually happen is, hey, we got glass lights fogging up, or we got cracked glass, or whatever. You got to get your butt out here, Mr. YKK. And I show up, and guess who else is there? Mr. Viracon or whoever the glass supplier is there too. He's going to look at it. He's going to say, take that glass off and let me look at the setting blocks. And he's going to look at the setting blocks and he's going to see one of a few things. He's going to see something that ain't supposed to be a setting block under there, or he's going to see setting blocks that have been cut down real small, or he's going to see setting blocks too close to the corners. And that's what he's going to say, and he's going to get his car and he's going to leave. And I'm going to say, I'm with him. Okay, so again, when it comes to the setting blocks that we provide meet the standard for what a setting block needs to be. If you cut that setting block in half, and I'm not accusing you of doing that, but are you cutting your setting blocks in half? Okay, so you are altering something that was prescribed. Now you're altering it, and it's not meeting the standard, and you're running the risk. And then the other thing I run into too, I'll get you in just a second. The other thing you run into too, and I see this all the time, even when they don't need to, is the setting blocks too close to the corners. And what the glass guys actually say is they want the glass located at quarter points, but no closer than 6 inches to the corner of the glass. Okay? So if you've got really, really long horizontals that are bending, you can move those setting blocks out. But certainly, please don't be cutting them in half. And don't go closer than 6 inches to the corner of that glass. Okay? Yes, sir.
Like when you have like a real small piece of glass.
Yeah.
Like a 6-inch piece of glass.
Yeah, that's different.
You can cut it.
Oh, yeah. Actually, if you read the literature, I believe that they have a formula or something like that. But remember, our installation instructions are based on what we call standard configurations, which is going to be in a typical storefront, a 4 or 5 foot wide light of glass that might be 8 feet high, it might be 6 feet high. those are going to be the full size setting blocks. But the problem I have is with the guys arbitrarily cutting them down and potentially creating problems. I don't usually get calls about that because they figure that out real quick.
Right.
You know, I'm just trying to prevent you guys from learning it the hard way. You know? Okay? Any questions about that? Also, when you put your setting blocks in, typically the glazing procedure is you're going to pick up your glass with your suction cups. You guys use suction cups, right? Okay. Just making sure. Okay. Go picking it up, and then you go into the deep pocket. You swing it over, get it centered or you get it in the opening to where you can lift it up, and then you're putting your setting blocks in or sliding it over into the shallow pocket. Make sure when you do that as part of your glazing procedure, make sure you take a good look at those setting blocks to ensure that both the inboard and the outboard light are supported by the setting blocks. It's easy to bump a setting block, and I've seen this happen before too, where the setting block has to support both the inboard and the outboard light. If it gets cocked crooked or if it gets bumped back, you may have either the inboard or the outboard light unsupported, and eventually it'll shear that seal. Okay? That's another cause for fogged up IGUs. Any questions about that? We must be getting close to the end, right? All right. You guys install the side blocks, the W blocks. Okay, a lot of people don't. That's okay. So here's the thing. What are the side blocks for? What is this? Okay, what you're basically doing with this, it's a W-shaped block. It's rubber. You take it before you put your gasket. You've got the gasket on the inside. You set the glass. Before you put the outside gasket in, you take this and you stretch it out and you slide it in between the glass and that glazing reglet on the outside, and then take your putty knife and push it all the way back into the glass pocket. Once it gets past the edge of the glass, it'll kind of pop back into that W shape and just hang in that glass pocket. Okay? Do you know why we do that?
Anti-walk.
Anti-walk, which means what? Keeps the glass from shifting sideways. Okay? There's a couple of what causes the glass to shift sideways is noise and vibration. So, like for example, if you're near the airport or there's trucks going by, or these kids that like the real noisy. This was a thing when I was a kid too. Glass packs on a '64 Mustang, right? That seems to be making a comeback, but they're doing it with the Toyotas and those cars. But the all of that stuff causes the glass to vibrate. And what can happen is over time, sometimes in a very short period of time, it can actually cause the glass to walk into that deep pocket. And then you do what? You lose glass bite on the shallow pocket side, or at the very least, you're exposing the spacer in your IGU, which is not attractive. Okay. There's another problem with it though too. Okay. The other problem is, remember the water deflector and what it's doing? What happens if the glass underneath that horizontal shifts sideways?
Seals it up.
Well, now all of a sudden you're dumping water from the water deflector on top of that glass. So you really need to kind of think about using the W blocks. The other thing is that sometimes what happens is you guys go out and do an installation, and 3 months later they're calling here going, "Hey, your guys, when they put the glass in, the glass isn't centered in the opening. We got daylight over here." Then what happens? You guys go back out there and recenter the glass. Okay? Do you get paid for that? I mean, you do, but does your company get paid for that? No, you should be out installing new work, not going out there correcting problems. So it prevents callbacks. It prevents problems with the daylight, between the edge of the glass and the glass pocket, and prevents leaks by putting those in there. And the rule of thumb is you should have one anti-walk block per light per deep pocket. So like in a storefront run like this right here, right? What do we got? We got a deep pocket, and we have a shallow pocket. We got a deep pocket and a shallow pocket. We got a deep pocket and another deep pocket. So here, you would get a W block here in this deep pocket. You wouldn't get one here, right? Because this is a shallow pocket. You would get one here in this deep pocket. You don't need one here because this is a shallow pocket. You need one here because this is a deep pocket, and you also need one there. So it's one per deep pocket per light. And remember, always at one end or the other, you're going to have two deep pockets facing each other. Okay?
We should inspect that, see if they're in there.
Well, there's no sill flashing, so. Okay. And this is just showing, remember the typical configuration for the storefront system is for outside glazing. Have you guys ever had to install them for inside glazing? If they want to install the glass from the inside? Yeah, you can do that. It involves, reconfiguring the system a little bit, the same components, but now what we've got is we have the glass stops on the inside, okay, for being able to set the glass. And notice that the glass stops are on the underside of the mullions. We don't want this to have the glass stop here because if you get water in the pocket, the glass stop's up here, it'll come through the glass stop and leak on the inside. Okay? That's it. You guys now know everything that I know about storefront systems. So there's no excuses. What do you think?
I needed that. We call them snake blocks. We do a lot of replacement work. So they're a nightmare. I hate them. But I understand why you need them.
Yeah. Sometimes you don't know if they're there or not.
Well, not a window wall. I call it a window wall where flush plate, we got deep pocket and deep pocket.
Yeah.
They put both of them in there.
Yeah.
Trying to replace a piece of glass.
Yeah. What you got to do is pull that gasket out and then take your hook tool and just slide them down out of the way. Yeah. So what do you guys think? Any surprises?
Hell yeah.
Yeah.
You have a lot of information you need to know.
Well, yeah. Okay, so that's why we're doing this. It's not to be a smart ass or to be funny or anything like that. But I think it's important. Like I said, and guys, like I said, I hope that I explained it in a way not just to say you have to do it this way, but now I hope you understand why it needs to be done that way. And I think that helps. I think it goes a long way to helping people, remember to do it instead of always having to be told to do it. Okay? Good deal. Let's talk real quick about doors, door installation. Okay? This is not going to be super in depth, and again, I would expect that most of this is stuff you guys already know, but we'll see. Is there a tab in there for entrances?
Yes.
Okay, good. Okay. So I don't think there's going to be anything here that's gonna surprise you too much. Not like the storefront stuff, maybe, but I think we all understand that the doors that we sell you guys are rectangles, right? There should be square rectangles, and so for the door to function properly, it needs to be installed in a square rectangle, and everything needs to be plumb level and square. Okay, and so what this is showing here. And what's interesting about this is I kind of like this. This is a very, very old diagram. Does anybody know what this is? That's a plumb bob. Anybody ever still use one? I got a nice one. But now they have lasers, right? You guys use lasers?
Oh, yeah.
Okay. Yeah, so lasers are a really good tool. And it's much easier to use than a plumb bob and all that good stuff. But basically what we want to make sure is we want to make sure that the frame is square and that it's plumb. Okay, so by square, we mean that if you were to measure it diagonally, dimension A should equal dimension B. If those two dimensions aren't the same, that instead of having a rectangle, you got a parallelogram. The problem is the door is not a parallelogram. The door is a rectangle, and it's not going to fit in the frame properly, okay? And so that tends to cause, if you're trying to fit a rectangle into a parallelogram, it causes the door to, typically it's going to be tighter in the frame, which is not a good thing, okay? The other thing is it's got to be plumb. I get a lot of phone calls from people, hey, we think the door is warped. I go, well, what is it that leads you to believe that the door is warped? Not that it's impossible that the door would be warped, but that's not a very common thing to have happen, especially if you've got glass in the door, okay? So we'll say, well, it's nice and it's fitting inside the frame at the top and along the hinge jamb, but at the bottom of the lock jamb, it's sticking out a little bit. Well, usually the reason it's sticking out is because that lock jamb is a plumb, okay? And so usually it's, or if they've got a pair of doors, one of the doors is sticking in and one of them is sticking out, it's almost assuredly because one of those door jambs is out of plumb, okay? So this basic thing, this is the most basic thing for installing doors. If you're having an 18-day where, you know, this is where you want to spend time. Hanging a door in there is monkey work, right? That's not difficult. But this needs to be plumb level and square for the doors to have a chance of functioning properly, okay? Also, the frame needs to be shimmed and anchored at the jambs or fitted into a frame that's shimmed and anchored, but certainly anchored at the top. If you have a receptor used, depending on your hinging hardware, you may also need to shim the door header or the transom head inside the receptor, okay? Because again, when you open the door, everything wants to twist, and we need the top of the door frame to be rigidly anchored, okay? Door jambs and the door threshold should be on the floor, okay? Remember we talked about the ADA, Americans with Disabilities Act, civil rights legislation that was enacted in 1991. Was anybody here not alive in 1991? Yeah, there you go. So yeah, like our industry and a lot of things about buildings changed overnight when the ADA was enacted, right? You guys may see some old doors where you have the push-pull hardware is a little bit higher up and the lock is up above. You know, you'll see stuff like that. But that wasn't the only thing. Handicapped parking spaces didn't exist. Ramps into buildings didn't exist. You know, the cutouts in the curbs so the wheelchairs none of that stuff existed. The handicapped people had to park out on the parking lot like everybody else and find a way to get into the building. So that's what the ADA addressed, those types of things, and also addressed our entrance products. And not only did it impact the height of the threshold, for example, but there were clear opening dimensions. Back in the day, prior to that, there were stock 2-foot 6-inch door packages. You could buy stock doors that were 2-foot 6 inches wide. Okay, you can't do that anymore, can you? Why not? Good luck getting a wheelchair through that baby, right? So there were a lot in hardware. The height of the hardware from the finished floor. The locks used to be up here. Now the locks are down there. Same thing. Latch locks were up high. Now the latch locks are down low. So with the doors, the thing is we have to have the threshold resting directly on the ground. And the reason for that is because the ADA states very clearly that the height of this cannot exceed how much? Half an inch. So if you're shimming your door frame up, or if you're shimming this threshold up, you're in violation. Okay. Now, with earlier, listen up. Earlier, we talked about the fact that the general contractor is providing us with openings that are not level, and we need to install the storefront framing level. So we do what? We reduce the size of the frames and we shim them to get them level. You can't do that with the doors, can you? So what do you have to do with the doors?
Tight to the floor.
What's that?
Tight to the floor. Tight to the floor.
Well, yes, but what if the floor's on a level?
Cut the door.
No, you have to have the general you can let the general contractor slide where the fixed framing goes, but where you got doors, he has got to provide you a level opening for that 3 feet or that 6 feet. I understand what you're saying. The alternative is what? What's the alternative to having the general contractor fix the floor? What?
Do it yourself.
There is no alternative. You would have to shim and do all the things that you're not supposed to be allowed to do. My experience has been that when the general contractors are told you can't install an ADA compliant door unless he levels that concrete, then they'll level the concrete. They'll grind it or do what they got to do to get it level. Okay? So just again, I understand. I'm just telling you the way it works. Okay? We definitely, even though the storefront itself is not water resistant, we certainly don't want water migrating under the threshold, so we will bed the threshold in sealant. Okay? Adjustment of the doors. Do you guys ever install offset pivot doors?
Yes.
You do? Okay, good. I like the offset pivot doors. There's a couple of things in particular I like about them. One guy can hang an offset pivot door, right? Easy peasy. The other thing is the offset pivot doors are adjustable on the hinge side. The other types of hinging hardware that you have, butt hinges, continuous hinges, things like that, there is no adjustment on the hinge side. The offset pivot, you take that little screw out of the top, and what's underneath there? A little Allen screw. You tighten that, you can raise this up, you loosen it, you can lower it down. Okay? Also, we can adjust, as we've already discussed, the lock side of the door, right? And the way we adjust the lock side is with that adjustment screw that's attached to that nylon block that you guys hate, right? This thing up here, okay? And so the way that works is due to the way we glaze the doors. When we glaze the doors, we don't put 2 setting blocks underneath this glass, do we? So we do what we call cross blocking, where we have a setting block underneath the glass on the hinge side of the door, and then there's a side block up here at the top, and this glass just kind of rotates and leans against that style. And so that nylon block at the top of the door should be just touching the glass at the top of the door. And if you need to raise this up, you tighten that screw and it lifts this side of the door up. The reason you can do that is because you're pushing down on the glass and there's clearance underneath the glass and the bottom rail that allows this to ride up.
You can reverse it too.
You can lower it too. Yeah. If you're rubbing on the header, you can reach up there and loosen that screw. Now, because of the friction between the gaskets and the glass stop and the glass, you may need to pull down on the door to get it to come down, but you can certainly adjust it down as well. Okay? Any questions about that? Okay? Well, we talked about this already. You know, even though the storefront doors aren't water resistant, we don't want water coming from the side lights into those areas. So pay attention to how you seal the end of your sill flashing to the back side of your door jamb. Sweeps. You guys are going to love this.
Great.
Sweeps go on the inside of the doors.
There it is.
Yeah.
Okay? All right. I got some believers here. Okay? So here's the thing. Let's talk about the sweeps on the inside. Okay? The sweep, the reason they call it a sweep is it's intended to sweep moisture and or debris off of the threshold. So if this is the interior and this is the exterior, the idea is that if you got any leaves or pine straw or moisture on the threshold, when you open the door, the sweep pushes it off.
What if it's an in-swing?
Well, if it's an in-swing door, it still goes on the inside.
Right, but it ain't going to push nothing.
It ain't going to push anything off, but what's it going to do? It's still going to provide an effective air seal on the inside. We don't test these doors for water infiltration, but we do test them for air infiltration. So when you have a door, and what's this right here? That's the bulb gasket that we have in the doors, in the door jambs, right? And we have a similar gasket running across the underside of the header or the transom bar. Okay, so we have these gaskets on 3 sides of this door, going up and down the stiles and across the rail at the top. Okay, we don't have anything at the bottom. So if you put your sweep on the outside, you've still got a gap between the sweep and the gasket that allows air to flow underneath that door. If you put the sweep on the inside, what have you got? You got a continuous seal all the way around the door when it's closed. Okay? So sweeps go on the inside. Okay? Now, if they want to put sweeps on the outside, then you can certainly do that, can't you? But I would recommend that that be done in addition to the interior sweeps. So if you go out and install a frame, they go, hey, you put the sweep on the wrong side. No, it's got to be on the inside. You can tell them all the stuff I just told you. Well, we want it on the outside too. Okay, that's going to cost you $200.
Why would you want it on the outside? They're ugly.
Well, yeah. Well, because they think they're not thinking of it. They're thinking it's a web. They think it's going to stop the door from leaking. Okay. And it's not. If they've got water infiltration through the door, putting a sweep on the bottom isn't going to stop it. There's a lot of reasons the door might be leaking. The most common reason is because it's getting water on it, or you're getting water on the transom. They go, does the transom drain water? No, it doesn't. We don't make the transom water resistant because the door isn't water resistant either. Now, if you want
water go from the transom if it gets into the glass pocket, like where the glass is?
It goes down to the bottom. Well, first of all, there's no path for it to take into the glass pocket.
It just gets, if it gets behind the rubber, it just kind of sits.
It just kind of sits there. And it'll come through the transom glass stops to the interior and drip off the inside. It might even drip and run under the transom and get into the top rail and leak up there too. So when people call me about leaky doors, oh, we got a leak at our job. Where's it coming in? At the doors. Okay, are the doors getting water on them? Yeah. Well, then they're going to leak. Okay. So when it's an architectural design problem. They need storefront doors are designed to meet code-driven access requirements, right? ADA, emergency ingress, emergency egress. That's what we're having to meet. Okay, they're not tested for water. If we tested them for water, then they'd have to have thresholds that were as high as our sill flashing, which is a lot more than a half an inch. So, well, balcony doors is something different. Balcony doors don't require aren't required to meet ADA requirements. Now that said, we do have like for example, we have terrace doors and we have sliding doors that have the typically high thresholds. We do have optional low thresholds for our terrace doors and our sliding doors, but you can't do like in-swing doors with them. They can only be out-swing on the terrace doors, and the performance potential is not as high as it is with the standard ones. And the reason we came up with that is because depending on how the building is going to be used, there are some FHA accessibility requirements that have to be met. Not ADA, but FHA, Fair Housing Act. So, for example, we did a project in Charlotte, North Carolina. I don't know, it was a 15 or 20-story condo that was being built. And they put our terrace doors in it. And as the construction was nearing an end, we had the savings and loan stock market collapse back in, 2008 or whatever the hell it was. And the building, the guy didn't sell all the condo units. He had some of them sold. He then decided to convert them to apartments and rent them out. Well, when he did that, the balcony accessibility became different. And so now the terrace doors did not meet the accessibility requirement for the balconies that it had to have because it was an apartment and not a condo. And so they wanted our customer that installed the terrace doors to take out the terrace doors and install storefront doors. You see where I'm going with this? Okay. So our customer said, I can't do that. He said, why not? He said, because they'll leak. And I said, he goes, are you going to do a water test? Yeah, we're gonna water test the doors. He goes, yeah, you can't get a storefront door to pass a water test. So they found another glazing contractor that says, those guys are full of crap. I can install a storefront door that won't leak. So he installed some storefront doors, and guess what happened? Yeah. Okay. So there are things, you know, and the other thing, in say FHA versus ADA. ADA is not just about the height of the threshold. There's other things too. Like, for example, you have to be able to open the door without having to grasp or twist something. So like any door in your house that's got a doorknob on it is not ADA compliant. But it doesn't have to be, does it? So typically with storefront doors, all you really got to do is hook into that pull handle and pull the door open. There's no grasping or twisting involved in it. Our terrace doors, you guys have operated these terrace doors. What do you got to do? You got to grasp, you got to twist. You got to do the same thing to secure them. Sliding doors, okay? You guys ever operated one of our big monster sliding doors? Okay? There's no, you have to grasp that and pull, and it takes a lot of force. None of that is ADA compliant. So the difference is accessibility into a building for ADA. FHA is just accessibility within the building for the Fair Housing Act. Okay? So they're different things and have different requirements. So door sweeps go on the inside. And it sounds like you guys are already in line with that. Closers. I'm not going to spend a lot of time talking about installation instructions on closers because it varies depending on the type of closer you've got, right? So when you guys get a closer, a box with a closer in it, what's that white thing that flows away in the wind when you open the box?
Instructions?
Yeah, that's the instructions in the template, right? Yeah, so these come in the box with the closer, and you know, God knows what kind of closers you use, and you might be using some of ours, you might be using Dorma closers, you might be using the LCN closers or whatever, but the instructions for how to properly mount those, to whether you're mounting it to the door and attaching the arm to the header, or mounting the closer to the header and attaching the arm to the door, you know, all of that stuff can vary depending on the actual manufacturer, okay? And so I'm just kind of showing here different installation instructions and the kind of information that they show for these different closers. Here's one from an LCN 4040. You guys have probably seen this before. In addition to the mounting instructions, they have adjustment instructions. These closers are all adjustable, right? So you have sweep speed and latch speed. Okay, so when you a lot of times the actual speed with which the door closes is dictated by code. Have you ever had anybody out there with a stopwatch timing how long it takes your door to close?
I've heard that.
Yeah. So what they'll do is there'll be a code inspector. He'll come out. He'll open the door. He'll let go of it, and then it has, you say 6 seconds, and that varies a little bit depending on where you are. But that door has to take 6 seconds to close. Why? If it closes too fast, then you got a guy with one leg or somebody in a wheelchair. It makes it more difficult for them to pass through the door. So it's about accessibility.
Pounds of pressure too.
Well, the pounds of pressure is a different issue that's related to
ADA.
Well, no, not really. ADA does not apply in terms of closer opening force. That doesn't apply to exterior doors. That's interior doors only. There is a local code that may say that it has to take, 8 pounds?
Between 6 to 8.
6 to 8 on exterior doors. So usually what I hear is 8 to 8.5 for exterior doors, because hell, a gust of wind can pull a door open if it's under 8 pounds. Okay, so usually there's a local requirement. That's not an ADA thing. ADA only applies to interior doors on a building.
With government, it was.
With the government, they might have used that guideline for the GSA, General Services Administration. But generally speaking, if you read the Americans with Disabilities Act, there's nothing in there about exterior doors. It's only interior doors. Okay, but again, the adjustment on the closers, typically you have 2 different adjustments. You have sweep speed and latch speed. So when you open the door to the fully open position at 90 degrees or 105 degrees, depending on the closer that you've got, when you let go of the door, from that fully open position, down to about the last 12 degrees is what they call the sweep speed. And that's what you want to be fairly slow. The last little 10 to 12 degrees is your latch speed. And what you want to do is you want to speed the door up a little bit for that. And there's a couple of reasons for that. One, you got the gaskets running around the door, right? If the door closes too gently, it's not going to seat very firmly into those gaskets, and you're going to allow for a lot more air to flow around the door. So you want it to slam just a little bit. I say slam, but obviously it doesn't need to be a slam that causes the wall to shake, but you need it to close with enough force to where it can seat the door into the gaskets. The other reason is sometimes we have securing hardware on the doors, like panic devices and latch locks, that require the door to close with enough force to trip the mechanism, right? So like, for example, concealed rod panics. Typically, you've got a little activator up here in the header. If the door closes too gently, it won't trip the activator, and the rods won't secure the door. So you need it to close with enough force to activate your locking hardware too. The same thing is true for rim panic devices and latch locks. If it closes too gently, it won't secure. Okay. And by the way, the other thing on rim panic devices is if you have a side light, you guys know what rim panic devices are, right? That's, you have the concealed rod panic devices where it's securing at the top and the bottom. The rim panic device is just a latch lock that secures either into a strike that's mounted in the frame, or if you have a pair of doors, a removable mullion. But if you have a single door with a side light into it, my advice is always make sure there's a horizontal mullion in the side light at that latch lock at the rim panic location. Because if you don't have a horizontal in there, what will happen is when the door's locked, somebody will come up and pull on that door, and since there's no horizontal in there, the door jamb will bump sideways and the door will just pull open. So it's always a good idea to have a horizontal in there, basically to stabilize that door jamb. Okay.
I got a question.
Yeah.
On that 6 seconds, that's for the full process or before it hits latch? Like, how does?
Well, that's from fully open to closed.
Okay.
Yeah. Okay. Do you guys do a lot of concealed overhead closers? Some, a little bit. Okay. We have a standard concealed overhead closer manufactured by a company called Caliber. So if you look in our entrances installation instructions, it shows you how the closer gets mounted into the transom bar, the door header. That's what that's showing there. This is the sweep and latch speed thing I was talking about. What's a back check?
It's an open speed.
Yeah, well, what a back check is it's something that's it's a feature that's built into the closer. You can either buy closers with or without back checks. And what it's for is it's from this position right here to the fully open position. When you open the door, you feel, when you get it open to this point here, you'll start feeling a cushioning resistance. And what that's for is to protect something like a wall that might be back here, or to protect the hinging hardware itself from the door opening with too much force. I don't trust back checks, the ones that are built into closers. Usually if you've got a swing control problem that involves the door opening too wide, you need to put a door holder on those things, either like a floor stop to prevent it from opening, or if you're in a traffic area, you may need to attach a Glyn Johnson. You guys know what Glyn Johnson door holders are? It's like a spring, it's like in a little rectangular box that mounts onto onto the transom bar, or it can be concealed in the transom bar. It's basically a spring to increase the cushioning. Okay, what we run into a lot of times, and the reason I say I don't trust the back checks, in an interior application they tend to be okay, unless you fire somebody and they're slamming open a door as they're walking out the door. But for typical operation inside of a building, a closer with a back check usually works fine. It's on the outside where you have problems with the wind grabbing the door. A back check and a closer isn't going to stop that from happening. So if you've got, again, swing control problems of that sort, typically additional hardware of some kind is going to be necessary. Okay. So this is the concealed closer. These are the adjustment valves for sweep and latch speed. It's usually stamped onto the body of the closer. There's an S or an L, or it might say sweep or latch. And so you just, turn them to speed up or slow down the sweep and latch speed. This is an old closer that we used to have. We used to have this Dorma closer was our standard. And I just put this in here because it was just an interesting contrast, because they've got on the end of the closer body, they've got the valves for adjusting latch and sweep. And then they also have, this one actually has an adjustable back check, which I hadn't seen before. That's kind of a nice feature, What's DA? Does anybody know what DA is?
Door angle?
Door angle?
Dual
action?
Delayed.
Delayed? You're right.
Yeah, delayed.
Delayed action. Yeah, so what you can do is you can have this, if it has an adjustable delayed action, when you open the door, you can speed up or slow down. It almost functions like a temporary hold open. So you open the door to its full open, and it'll stay open for a period of time, and then it'll automatically close. So that's delayed action. They're talking about the delayed closing of the door, which I think is a pretty cool feature. Okay. Typically, they'll have something like this on the closer. You guys know what's inside of a closer body? There's a big giant ass spring under a lot of tension and hydraulic fluid, right? And I typically don't like to see people messing around with those, okay? Because if you go too far with it one way or the other, bad things can happen. So.
And they shoot out at the side.
Yeah. I saw one where it knocked a hole in a wall, a cinder block wall.
Gotcha. Too many turns.
Yeah.
Sometimes you have to do it though. If it's like a real heavy door and like you don't have a closer that's like the right size for that door.
Yeah.
You have to adjust the power to like be able to close.
Yeah, I know you have to. I'm just saying, make sure you know what you're doing before you just start turning the shit out of it.
Yeah.
Well, by the way, while we're talking about that kind of thing, we didn't talk about this earlier. I'm not a big fan of using impact drivers for assembling storefront frames or installing curtain walls. Okay, I think impact drivers are great tools for driving Tapcons into concrete. Okay, I don't think they're the best thing that you can use for screw splining frames together or putting pressure plates on the mullions. And the reason I say that is because the torque potential in that tool can be very aggressive for what we want it to be. And let me give you some examples of where it's something that's come up. Well, we don't use impact drivers on our shop floor. What do you guys use down here?
Impact drivers.
You use impact drivers? Okay. As long as you're watching the torque. I mean, if you know what you're doing and you're watching the torque, like I said, it's a fine tool. The problem I have is when guys are just going real fast, the speed and torque tends to create problems, just the speed and torque. And I'll give you a couple of examples. And if you've heard me or if you've seen this yourself before, you'll know exactly what I'm talking about. Have you ever seen a storefront horizontal mullion where you've got like a crazing right where the screw splines are going in on top of the horizontals? Have you ever seen that before? You know what causes that? Too much torque. Too much torque on the screws. The other thing, and this is even worse than that. Okay, usually what happens is it's like first people argue about whether or not they're actually seeing anything. Well, you can see it from this angle, but you can't see it from this angle. You know what I'm talking about? It's there though, and I found that I didn't know what the first couple times I saw it. I didn't know what it was until I talked to the guys in our shop. In our shop in Dublin, they use air guns. Everything is pneumatic, but and that's one of the reasons why. Part of it's tool cost, but the other is because of torque. The worst is on pressure plate screws and curtain walls. We had a customer in Texas, and he was doing a huge curtain wall project, and they were up on lifts putting pressure plates on for days, doing nothing but screwing pressure plates on. They get done, they snap on the covers, they start doing water tests a couple of weeks later, and water's coming in everywhere. Right? And this was, by the way, this was a very large professional glazing contractor. I would consider them on a scale of 1 to 10, they're probably an 8.5. Okay? 10 being like perfect. They're very, very good. And so the guy, they didn't even want me to come to the job site. The guy says, look, either we've got a tolerance problem that's not apparent to us, or there's something else going on. I said, where's the water coming in? And he's describing it. And usually it's like, well, it's just coming in at this corner, or it's just, this water was coming in everywhere. And I said, I want you to do this one thing that the guys never do. I said, I want you to do one thing for me. I said, go out there, get a torque wrench, and I want you to check the torque on those pressure plate screws. Yeah, I don't know if you guys knew this or not, but there is a specific torque that you're supposed to have on the pressure plate screws. Okay? And we'll talk about that when we talk about the curtain walls. So the guy goes, okay. He goes, I'll do that. We got a torque wrench here. And he said that he had 2 torque wrenches. He had one that had a gauge on it, and the other one was just one where you turn it till it clicks, right? So he went up the first time with the one you turn it where it clicks. And he said he turned it and 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 it never clicked. And he checked like 5 different areas, and probably 3/4 of the pressure plate screws were stripped because they were ramming them things in with impact drivers. Okay, so I'm not advocating the tool. I'm just trying to educate. Okay, I know you guys are using impact drivers. I'm a little surprised you're using them in the shop, but that's okay. Just make sure you're watching the torque on those things, because you can be stripping out those pressure plate screws and not even realize it. Okay, especially if you're not doing anything in the field to monitor the torque. Now, different customers do different things, and we'll talk about that when we get to the curtain wall installation stuff. Okay, but yeah, the impact drivers, you know, I've seen too many problems caused by them, and I've got a number of customers that have told their guys they can't use them anymore. You know,
they did start getting this gun that had different levels, though.
Yeah, and that's what I'm saying is, it's not so much the tool itself, it's how it's used. And educating you guys and making you understand that, hopefully that'll get you keeping your eye on the ball, you know, so that you don't have those kinds of problems. Okay. This is just something interesting I was going to tell you about. This is you guys recognize this? That's our old thermal door. That's 35XT. Okay. This is our curtain wall system, YKK 750OG. This is what's this right here? Anybody know what that is? What do we call that?
Door frame?
It's a door frame. We call it a subframe adapter. So if you have a curtain wall, we put this subframe adapter in if you have doors. Okay? And in this particular case, what was happening was the customer was complaining because the doors were rubbing against each other in the middle. Right? And he thought maybe we had made the doors the wrong size. He goes, we measured the opening, you know, everything's, you know, we installed everything, it's all plumb level and square, you know, all that stuff that you typically look at. He goes, but we got the doors rubbing in the middle, and it's a problem. So I happened to be in the area, went and looked at it, and I was out there and I could see, you know, where the doors were rubbing. And I said, wow, that's something. And so what I ended up doing was I ended up measuring the opening dimension, and then I actually measured the door leaves themselves. Okay, and I called in to the product engineer and I said, if I have a door opening of a certain amount, what size should the door leaves be? So I have a door opening of this, what size should each door leaf be? And he told me, and guess what? Everything was right. So how the hell is it that those doors are rubbing in the middle, right? And I didn't know. I didn't have a clue. So I'm on the company's quality conformance committee, although I don't go to the meetings anymore, but I used to go to them all the time. And I was at a meeting, and I was listening to him talk about some window issue or other. And they said, Bart, have you got anything going on? I said, yeah, I got a question for you guys. I got a job where the doors are rubbing in the middle. And, we measured the door opening, and it's right. And I measured the door leaves themselves, and that's right. And according to engineering, the door leaves are the proper size. How the hell could they be rubbing? And this one guy sitting in the back of the room, he goes, are them XT entrances? And I go, yeah. He goes, is it installed in a curtain wall? And I go, yeah. He goes, has it got that subframe? And I go, yeah. He goes, has it got continuous hinges? And I go, yeah. He goes, I know what the problem is. So if you look at this, you guys install continuous hinges, right? You get it comes in a box, and you got the self-drilling screws, right? So here's what's happening. Notice the subframe. This part right here that I'm highlighting, that's the actual meat of the subframe. What's this thing right here? No, this right here. This is just a snap-in plate to conceal the fastener. Okay? So
leather stripping on it, right?
yeah. So what was happening was the screws that came with the continuous hinge are these short little, I don't know how long they are. Are they an inch? Yeah. So what was happening was on the door side, they're getting good bite. On the jam side, we have, notice in this diagram, I have longer screws. That's the remedy. Okay. If you have the short screws, this tip part that does the drilling, all that does is go into this. It doesn't bite into that. So I go, so they're explaining this to me in the meeting. I go, oh, so what's happening is when they open the door, since these short screws are being used, it's causing this to bow out. And the bowing out is what's causing the doors to rub in the middle. Yes, sir.
So when you're on the new thermal doors, putting a continuous hinge on the new thermal doors, one side of the screws all drill into the brake because of where the brake's at, with like a Hager root on it, or like a Hager continuous hinge.
It's drilling into the brake?
Into the brake. You split it 50-50.
Okay.
So
thanks for letting me know.
you guys are probably going to run into that same problem.
All right. No, well, it'll be a different problem, but you're right. So what in this case, what I did was I called, and so our remedy to this problem is if we provide the hinges, then we also provide the 2-length screws. Okay? But if we're not providing the hinges, which was the case on this other project, then they're getting these short screws, which are no good for this side. So I told the guy, just a second, I told the guy to get these longer screws, and he did. He goes, yeah, now I got another problem. I go, what's the problem you got now? He goes, yeah, that fixed the problem. He goes, but now I got another problem. I said, what's that? He goes, his guys had ground the edge of the door off to keep them from rubbing. Now he's got a gap. Yes.
Basically, you're not getting any grab at all with the new style thermal doors because it's drilling that brake and that's like plastic or whatever it is.
Okay, I understand. I understand. I'll talk to him about it. Okay. Thanks for bringing that up. Okay.
Good job, Chino.
Okay. We good?
Yeah.
All right. You guys want to take? I tell you what. I don't know what time they plan on having lunch come in. Why don't you guys take another about a 10-minute break, and I'll bring up the next presentation, and we'll start that till they come in with lunch, okay? I don't know. I'd have to check and see. Yeah. Yeah.
Cover up a lot of. But
Yes. What I would recommend you do is talk to whoever your project manager is, and because that you have to be an engineering solution, and your project manager can talk to our engineering department. And if we have a two-piece receptor that works with that, then
Because I know, like, we're doing.
Yeah.
Well, Arcadia, and
Yeah.
they have them, so we're.
You bet.
Thank you.
Yeah. Good, sir?
Mm-hmm.
Can I get you anything? Okay.
No.
All right.
Me and your guys are learning about a lot about each other here.
That's awesome. They're a good group.
They are a good group.
Yeah, they are.
Very conscientious.
Yes, for sure. We're very fortunate. Yeah. Yeah, they are.
Hey man, I gotta ask you a question.
What's that?
Did that hurt on top of it? Yeah.
But they say you have a lot of nerve endings.
Yeah, I can only do like an hour at a time.
Wow.
This one took back here by 3:45 hour minutes to the session, but pretty much all of it.
Yeah.
Like I got up here and I started doing the leaves and my eyes were watering.
Oh, I'll bet.
Numbing cream and all that stuff.
Is that the most painful one you got?
Yeah, it's up there. Definitely top 5 for sure.
But they say it's an addictive pain.
I don't
Tattoo.
know. I hated it.
You hated it. That's what I've heard. I don't have a single one, but I've heard that
I like
it's
having it. I don't like it.
okay.
Yeah, that's pretty much it.
That's what it is. Okay. Yeah, the college roommate, she was like, "Oh, come on." She was like, "It's like addictive. Once you start."
Well, it's not. It's having like.
Yeah.
Yeah. You're looking at it all the time.
Yeah, you
People are like,
enjoy-
oh man, that's cool. Like.
Yeah.
That's what's addictive.
Okay. Yeah.
I just, when I was in the Marine Corps, I went with guys when they got their tattoos. And it was like, come with us. You're going to want to get one too. And I stood there and I looked at the tattoos on the wall and I watched them get them. I'm like, no, this is not making me want to get one worse.
Yeah.
Yeah.
I told my kids, I'm like, you didn't get tattooed? And they're like, no. I'm like, well, cool.
Yeah. You know, my problem is I can't commit to anything that much.
I'm like, I see something that looks cool.
Yeah.
Like I was at the shop and there was like a big cobra thing. I'm like, yeah, I want that. Put it on my shit.
Oh,
You know what I think of when I see tattoos? Is I want to invest in tattoo removal technology.
Oh, yeah.
Because at some point it's going to go out of style.
Yeah.
You know, when I was a little kid, I would go to the bowling alley with my parents and see these truck driver guys with tattoos, but they were the only, or Navy guys. They were the only ones that had tattoos.
Yeah.
So it became a fashion thing. You know how fashion is.
Yeah, everything comes back.
It's only getting, people aren't getting them removed, they're getting them covered up. They're getting what's called now a blast over. I'm going to do it with my arm eventually. Because I'm just tired of them. I don't want to get them removed, and I don't want to get them covered up because there's a lot. So what I'm going to do is like they call it blackout.
Yeah.
So most of it is just black, but then I'll have negative like I want to get this flower on my hand, so you'll see the tattoo underneath.
Oh, okay.
So you'll be able to see all my old tattoos, but most of it is black.
Yeah. I just saw Mark Wahlberg getting all his removed.
Yeah, Pete Davidson too.
They hurt so much.
I heard it's very
I feel
painful to
differently
have.
I feel differently about these tattoos now that I got kids.
Yeah.
They don't bother me.
Yeah.
Kids have been around like all my friends were all heavy guys.
Yeah, it's just like,
It's not.
it's like your personality. It's what you are, you know? Yeah. That's cool. All right, well, you let me know if you need anything. What time do you think? Lunch will be here probably around noon.
Okay.
So, but we can hold off, like, another 40.
No, that's okay. I just gave him a 10-minute break. And I can start this next topic.
Okay.
And then, just when lunch gets here, just let us know. We'll just take another break.
Okay. All right. Good deal.
Then are they eating here or?
So, they can, the lunchroom isn't quite big enough for everybody, but they can spread out and do as they want.
Okay.
They can either eat in here or they could go down to the lunchroom. So, wherever they're most comfortable. I tried to set up as many tables as I could in the lunchroom.
Do I need to, is there a prescribed time to give them for lunch? Like, do they have to have an hour? Or?
They do not. Most of these guys usually take a half hour.
Okay.
So it's
I'll give them a half hour, 45 minutes.
Exactly. I do think though when we come back from lunch, I would like to take just one big photo of everybody before you get going again and before the end, because at the end of the day, we're going to
Sure.
get out of here, you know. So I thought we'll do just one photo
Okay.
and
That works.
and then you can get going again.
Okay.
So.
And then are they expecting this to be done by 3 or something like that? Or what is the expectation?
No, I mean, I think between 3 and 4,
Okay.
you know,
Okay.
I think, you know, they'll get paid overtime for anything
Okay.
that goes past their day.
Okay.
So, just some of them have to travel.
Mhm.
So maybe some of them may have to cut out a little.
Okay. I'll try to wrap it up by around 3:30.
That would be great. I think that would be ideal if
Okay.
you could.
Okay.
All right. Very good. Fantastic. All right. Thanks, Bart.
You bet. What are those guys doing? They had sandwiches?
Yeah, lunch.
Oh, they must be getting lost.
They must have brought the lunch in. Well, hell. If lunch is here, maybe we ought to just go ahead and break for lunch now.
Not to and she got kind of fuck you, you don't even know it. I've never seen that. Like when you did that, you don't consider something that way. I'm not gonna honor you now.
We're going to go ahead and break for lunch now. And we'll start back at 12:15. Okay?
Did you meet the issue?
So originally, I came back there.
It's not. Right. So 5 years. You know,
That's who, you're like, yeah. So, as you
I'm saying like two I know, there's tension. Go home, right? Like, right? It goes to be a safe space, comfortable. So that stress on your dash.
Don't you hate, son? This is what happens when you get to work on time.
Look at your whole stuff. Yo, you're silly now. So I'm saying, when you're in it, it's the worst. You go through it, it's the worst. You know, this is 7:30 in the morning. And it's really like people are coming up. It's just about how you gotta beat that bullshit. The only thing that is guaranteed from the world is what? Death. From the world, everybody's going to guarantee that fact. It's just, you gotta overcome all that once.
They broke it up to
You say you think it will be like, well,
So I thought it's
What I'm saying is, do I need to call Mario? You guys should have went to the reviews. You need to get somebody down there to certify this. Not that it really means anything, but. Show you there, you don't do anything. Just like it.
Yeah, we should have been taking shots every time you said something we didn't do.
14. 14.
Oh, yeah. Just gonna sink it.
Who are these guys? They're doing shit.